Hello and welcome. My name is Stephen Greider, and I'm going to spend the next couple of hours telling you every last little bit of knowledge I have about MongoDB. Before we get started, there's two quick things I want to go over. First, how to get help, and then take a quick look at our GitHub reference repo for the course. So first, how to get help. You can get help in this course either by reaching out to me directly on Udemy, so send me a direct private message, or you can post on the course's discussion page. In either case, I'll be sure to get back to you as soon as I possibly can. Do note that one of the most important things for troubleshooting any issue you might have is your course's code or your project's code. If you can post your code up on GitHub ahead of time, or just include the relevant snippet in the message that you post to the forums or the message you sent to me, it's always a huge help. Now the GitHub reference repo, let's check this out. I've got a link right here. There's no need to type it in manually to your browser. The next lecture will have a direct link to it that you can click on in just a second. I'm going to pull the link up inside my browser, and let's just take a look at the code really quickly. So once I get to this GitHub page, you'll see a couple of different folders inside of here. Each folder represents a different project that we'll be working on. So if I click on this users directory, you'll find a bunch of code inside of here already all put together. All of the course's code is organized by branch. So you can see if I click on the branch manager on the top left-hand side here, you'll see a bunch of different branch names, all with a different number and description next to it. Each number represents a lecture number, and the text next to it represents the title of a lecture. So if you ever want to look up the project's code, at a very specific point in time, like for a very specific lecture, you can come into this user interface right here, find a very particular branch, click on it, and this will be all the code that corresponds to that very particular video. And so with this, you can always make sure you don't fall behind. If you ever watch a lecture and feel like, what exactly changed here? You can always come to GitHub and check out exactly what happened. Okay. Let's continue in the next section and get started on working on some real code. I'm sure you're eager to get to coding, and let me tell you, I certainly am as well. But ahead of time, we need to do just a little bit of software setup. In particular, we need to get Mongo installed on our system. So in this section, we're going to walk through the installation of MongoDB on the OS X operating system. So if you're using Windows, pause this video right now, go on to the next section where we're going to cover installation on Windows. So let's continue now with doing the OS X setup. There's a couple of pieces of software that we're going to be installing. First off is Brew, a package manager. This package manager is used to install other pieces of software and libraries on our operating system. Brew is very handy, very easy to install, so this will only take just a couple of seconds to get going. Once we have Brew installed, we're going to use it to install both Node and MongoDB as well. We'll be using Node mostly for tooling of our applications and packaging and kind of stuff like that. And MongoDB, of course, hey, that's our database. What else would it be? Finally, we'll also install RoboMongo. RoboMongo is a GUI for browsing the contents of our MongoDB databases. And so in practice, it's just a very helpful development tool. Now, it's not strictly required for this course that you install RoboMongo, but I suspect once you see it in action, you're going to want to use it. So we'll walk through installation of that as well. So let's get going with Brew. Like I mentioned, the Brew installation is really not that bad. I'm going to open up my web browser, and I'm going to navigate to brew.sh. Once here, I'm going to scroll down slightly to the Install Homebrew section, and you can see this big old long string right here. This is an installation script. All we have to do is copy this. So I'm going to hit Command-C to copy it. And we can paste it at a terminal prompt to install Homebrew automatically. I'm going to flip over to my terminal. So here we go. Here's my terminal. I make use of iTerm. If you use the built-in OS X terminal, that is totally fine. Absolutely no difference. You'll do fine with either one. So once I have my terminal open, I will paste the installation script and hit enter. Now I've already got Homebrew installed, so I'm not going to go through this particular process, but certainly if you do not have Homebrew already installed, just hit that return key and go through the process. It'll only take just a minute to download and install. Once that's all done, we can move on to our next piece of setup, which is going to be Node. Now, it's probably pretty likely that you've already got Node installed on your system. If you do, no problem. We're going to walk through the installation anyways. So back at my terminal, I can run brew install node. And so this is how we use Homebrew to install packages. We access the library or the package manager with the brew keyword. We say that we want to install a package, and then we just list the package that we want to install. So I'll run brew install node. And I already have Node installed. Oh wait, I forgot. I do not have Node installed. My mistake. I want to go completely fresh. So I took off Node, MongoDB, all that kind of stuff. I don't have any of it on my system. If you already have Node installed, I do recommend that you update your version of Node if you have a version older than version 4. And you can check your current version by running node-v. So you can see in this case I've got version 7. If you have earlier than version 4, I do recommend you update it, and you can do so by running the command brew upgrade node, like so. Okay, so that's Node. Not too bad, right? Well, let me just say, we definitely saved the hard one for last. So the MongoDB setup is a little bit more involved. So let's get started on it right now and just try to get it done with as little pain as possible. Honestly, it's not that bad. It's not that bad. Okay, so we're going to be using Homebrew to install MongoDB as well. So I'll run brew install Mongo, or just Mongo by itself. So this will reach out, grab the Mongo archive, there we go, and install it on my system. So installing Mongo is not the hard part. What the hard part is actually running it. Okay, so boom, just like that, it's installed. But again, that's the easy part. Now we got to do the hard part, which is the installation process, or the setup process. So once we have Mongo installed, we get automatically access to a program at the terminal that's called MongoD. When we run the command MongoD, that is going to start up a local Mongo server for us. So let's just go ahead and give it a shot and see what happens. So I'll run MongoD, and I immediately get a big old bunch of output back here. Chief of which, you'll see kind of right here, one of the very last messages that I see is data directory /data/db not found. So this is a little bit of a nasty part of Mongo. By default, it requires to have a directory on your hard drive where it can stash all of its data that it's supposed to be holding. By default, the /data/db directory does not exist, so we have to manually create that directory ourselves. We can create this directory by running the command sudo mkdir-p, and we're going to put on /data/db. Do make sure that you get the first / in there. If you don't put that first / in, it's not going to work quite the way we intend. So let's run this. I get prompted for my password, no problem. And now that creates the directory. So now I'm going to run MongoD again to try to start up my local MongoD server. And again, we get a nasty little error message, but this time it's a little bit different. It says, unable to create or open lock file, something, 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 permission denied. So the permission denied here is the key part. Although we just created the /data/db directory, we don't actually have ownership over it. And so MongoDB is saying, hey, I can't create a file inside this directory. I acknowledge that this directory is here, but I can't create this file inside of it. So we have to actually take ownership of this directory. So this is obviously this is kind of the nasty part here. So taking ownership of this directory is a two-step process. First, I'm going to run the command, who am I? This will tell me the username of the currently logged in user on my operating system. So for me, it is Stephen Grider, which is my name. For you, it's whatever whatever name you gave yourself when you first set up your computer. Now we can run a command to take ownership of the /data/db directory, and we're going to be using this username here as well. So we're going to write sudo change ownership, or chown. We're going to pass in the options -R and V. Then we're going to list out the username that we want to give the ownership to. So for me in particular, it's going to be Stephen Grider. For you, it's going to be whatever was returned from the who am I command. So I'm going to put Stephen Greider. Again, that is just for me. Yours will be different. And then we'll list the directory that we want to change ownership of. So I'll put /data/db. Again, really do make sure you get that first leading slash in there. So now we'll run this command. And there we go. The purpose of the -rv right here was to just print out a list of all the directories that were updated. And for us, that is the data/db directory. So now I'm going to try starting up MongoD again. And this time we get a whole bunch of text scrolling, but the very last line this time around says, waiting for connections on port 27017, which means our Mongo server just successfully started up. Perfect, just what we wanted. So there's one last thing to be aware of. I'm going to close out my server. I'm going to flip over to a little diagram. So this is a diagram differentiating two different approaches that we can take for the very last step here. And all it revolves around how we want to start up our MongoDB server. So I'm going to present you with two options, and I'm going to leave it up to you which direction you want to go with. Okay, so it's totally up to you. I'm just going to give you the options, and for the rest of the course, I'll leave it up to you. As we just saw, we can start up a local instance of MongoDB by running the mongod command at the terminal. The thing is that we can freely start up that server at any point in time, right? I can say MongoD, and I can freely end it at any point of time. If I ever start up the server and then say close out this terminal window, that's going to stop my server from running as well, which might not be what I really want to have happen all the time. To avoid having to stop and restart my server all the time, I can instead use a part of brew called the services. So I can run the command brew services start Mongo. And when I run that command, Mongo will automatically be started up for me at any time that I start up my computer. And then anytime in the future that I restart my computer, brew will automatically start Mongo up again as well. So maybe it makes a little more sense what this diagram is getting at now. We can either use brew services to manage Mongo, in which case we run that one command and never have to worry about anything again. And if we want to stick with MongoD, we have to run it one time and then keep on running it again and again and again over time as well. So again, I'm going to leave the choice up to you. For me, I think the choice is pretty clear. Make use of brew services start Mongo so that I don't ever have to worry about starting up the server manually again. And so I think I'm going to go in that direction personally. So at the command line, I'm going to run brew services start Mongo. And then we'll just see a result here, successfully started MongoDB. And that's pretty much it. So now anytime I restart my computer or I close out my terminal or whatever it might be, MongoDB is going to be automatically started up for me by Homebrew. Okay, that's it for our setup. Just one last time, I'm going to mention it because I won't say it too often again. If you choose not to use services here, if you want to go with starting and stopping the server manually, just remember for everything for the rest of this course, I'm always going to be assuming that you're running MongoD. So it's going to be up to you to remember to run that command ahead of time to make sure your Mongo database is running. All right, so let's continue the next section where we're going to do our setup of RoboMongo. In the last section, we finished up with our MongoDB setup on OS X operating system. There's one last piece of software that we're going to install that's going to help us out tremendously during the development process, and that is RoboMongo down here. The purpose of RoboMongo is to give us a graphical client to look at all the data that is sitting inside of our database. So it's something that we're solely going to use for development, just to give us a hand on figuring out what data is sitting inside of our database. Installing it is definitely easier than the MongoDB setup is all I'm going to say. So let's get to it. It'll only take a second. In my browser, I'm going to manually navigate over to robomongo.org. And then once here, I will find the download link very prominently placed on the main page here. So I'll hit download and then select the latest version that's on here. So download, and that's it. I'm on Mac. I'll make sure I download the Mac executable here. We'll download the file, and it's only going to take a second. It's only 16 megabytes large. So I'll open up the archive. And then installation is pretty darn straightforward. All we got to do is drag RoboMongo over into the applications folder, and that's pretty much it. Not too bad, right? Now, just to make sure everything is working a-okay, I'm going to start up RoboMongo now. So I'm going to open up my applications. I'll search for RoboMongo. And we get presented with a security warning right here. I can click open right here, so I'm going to click open and open the thing up. If your installation of OS X does not present you with that open option, if it just says, hey, you can't open this file because you downloaded it off the internet, no problem. We just need to update a quick security setting. So if you saw that message, if it said, hey, can't open this thing at all, you can come up here to the apple at the top left hand of the screen. You'll click on System Preferences. This will open up this System Preferences window. I'll find Security and Privacy on the top right hand side. I'll click it. I'm going to click the lock down here to make changes while also putting in my password. And then you'll probably see a button right here, something that says, hey, you just tried to open up RoboMongo. Are you sure you want to open this? And there'll be a button there that says, yeah, I want to open this. So just go ahead and click it and you'll be good to go. So again, you only have to do that step if OS X gives you a little bit of complaints. Now, once we've opened up RoboMongo, it's likely that you've already got an existing server in here. Usually RoboMongo will populate this option for you, but I'm going to assume that nothing is there. So we're just going to assume nothing is there. Again, if you have an option, totally fine. Otherwise, we're going to walk through creating a new database connection. So I'm going to click the Create link on the top left-hand side of that window. And then all the default settings in here are A-OK. The only thing I'm going to do is rename the name of the database to local, like so. So I'll save it. I'll select local, and then I'll connect. And all of a sudden on the top left-hand side, we get a list of all the local databases that are sitting inside of our MongoDB instance. One thing that I want to mention is if the connection fails to be made, remember, we have to be running either MongoD at our command line or be using the brew services setup. Okay, so one or the other at this point in time in order to be able to connect to our database. So there's not really any data inside of here yet that's going to be at all interesting to us. So let's continue in the next section, and we're going to start working a little bit more on our first application and try to answer the question, what is MongoDB and what is it doing for us? So I'll see you in the next section. In this section, we're going to go over the installation of MongoDB in a Windows environment. So if you're using OS X right now, hey, no problem, continue on to the next section where we'll continue with the course. If you're still using Windows, stick around, let's get to it. The first thing we need to do is install the MongoDB installer. In my browser, so I'm inside of Chrome right now, I'm going to do a search for MongoDB. And the first result that's going to pop up is, of course, mongodb.com. I'm going to go directly there. It's always really interesting. Their page loads amazingly quick. Very impressive. I don't know what they're doing, but very, very fast loading page. Anyways, on the very top right hand of the page, I'm going to find this download link and click it. This will take me to the download page for all different installations of MongoDB and all the different associated tools. Once I'm here, I'll scroll down just a little bit and I'll find under the Community Server section and make sure I'm on the Windows selector. Now once here, you'll notice that the pre-selected version is Windows Server 2008 64-bit and later. So this is a little bit misleading right here. Even though it says Windows Server 2008, this is still 100% compatible with both Windows Vista, not Windows Vista, but Windows 8, Windows 10. So if you're on Windows 8, Windows 10, you're good to go with just selecting this right here with the default selection. So I'm on Windows 10, so I'm going to go with this selection. Let's say download MSI, and that's going to download the installer. And it's going to take just a minute to get. Okay, very good. Once I've got the installer, I will just basically click through. So we can do next, accept the terms. Of course, if you want to read it all, feel free to go for it. And then once you get to this complete or custom installation, we'll go with the complete selection. And then last step, just go ahead and click install. If you get any user account control prompts, of course, just let it on through, and the actual installation will take just a moment. Once it's all done, finish, and that's pretty much it. I gotta tell you, the installation on Windows is a lot easier than it is on OS X, or at least in my opinion. There's just one last little piece of setup that we have to do. In my browser, at the thank you for downloading page right here, I'm gonna go back to where we were just a moment before, where we've got the download link. So here it is right here. Right underneath the download link are some installation instructions. So there actually is one last little piece of setup we have to do, and these installation instructions are going to help us out with getting through it. So from here on out, the directions that we're going to follow are exactly as listed on this page right here. So if you get lost at any point in time, you can feel free to come back here and make reference to the setup listed. Now we've already downloaded and installed this community edition thing, so we're going to go down a little bit more. Aha, here we go. So run MongoDB Community Edition. This is what we're looking for. I'm going to go to step 1 right here, and it says set up the MongoDB environment. Very important right here. MongoDB requires a data directory to store all data. This is one of the many big gotchas that we're going to find with MongoDB. So by default, when you install Mongo, it installs the database on your machine. But you have to give MongoDB an actual location to store all the data that we are going to try to insert in it. And that's what it's referring to here with this data directory. So by default, it wants to stuff all of the data that we're going to try to store inside of MongoDB into a folder called data/db. Chances are, on your operating system, you do not have this folder already exist. So we need to make sure that we create this folder so that MongoDB has a place to stash all of its data. So to do so, we'll follow the exact directions that are listed here. I'm going to start up a command prompt by hitting the Windows Start button, and then I can just type cmd and open up the command prompt, like so. Once I've got the command prompt open, I'll follow the directions listed on the page by writing make directory /data/db. Okay, not too bad. The next thing we have to do is start up the MongoDB server. So if I scroll down a little bit more, and I'll get to the Start MongoDB section. This part is awfully important, okay? So this is the one thing in this course that's going to be a little bit troublesome as we go out throughout the next 10, 12, however many hours that we'll be talking about Mongo. Depending on your operating system, like whether or not you are on OS X or Windows, you will be starting up MongoDB slightly differently, okay? Slightly differently. If you are on Windows, as you are right now, like of course you're on Windows, so no problem there. To start up MongoDB, you are going to run this command right here, or this string, inside of your command prompt, okay? The reason this is so important is that for everything inside this course, like everything, every last section, I will always assume that you are running this Mongo server, or your local instance, your local copy of MongoDB. I'm not always going to be saying specifically to you like, hey, make sure you got MongoDB running. So sometimes it's going to be up to you. Like if you step away from the course for a couple days and close out the command prompt, you are going to have to remember to start up your MongoDB instance again. Okay, so this always has to be running whenever you're working on this course. So it might be a good idea to copy paste this thing or bookmark the page so that if you ever need to come back to this command, it'll be real easy to find. So that's kind of caveat or big gotcha number 1. Now there's one other big gotcha. Okay, one other big gotcha. If you look closely at this link right here, you'll notice that it has 3.2 in this string. So at the time that this particular video was created, the latest version of MongoDB was version 3.2. If you're taking this course at some point in the future and you just installed like MongoDB 3.3 or something like that, this link or the command that you're going to run to start up MongoDB is going to look just a little bit different. To confirm which version of MongoDB you have installed, it's really straightforward. We're going to open up a file explorer. I'm going to navigate to my C drive. I'm going to open up my program files directory. Inside of there, I'll find the listing for MongoDB. Here it is. I'll open the server folder, and boom, right here. This is where you're going to find the version of your installed version of MongoDB. Okay, so you might be something slightly newer. Hopefully you are at least 3.2. So now I'm going to take this link right here. I'm going to copy the whole thing. I'm going to take it over to the command line. I'll paste it and then run it. The very last line that I should see at this point in time is something like waiting for connections on port 27017. If you don't see something like this, if you see an error, then the first thing to do is make sure that you've got the correct version listed in that string that we just pasted in here. Okay, so if you are on a version besides 3.2, make sure you update it in this link right here to correspond with whatever version you've got in your MongoDB server directory. If you do have the correct version there and everything does look good to you and you're still getting an error, feel free to make a post in the course's discussion and we'll do a little bit of troubleshooting to figure out what's going on. Okay, that's pretty much it. We've got MongoDB installed. Not too bad, right? The last thing that I just want to remind you, anytime you're working on this course, you need to make sure that you've got this command prompt open and that you have ran this MongoDB command right here, or this MongoD to be specific command. Okay, let's continue the next section, and we are going to install a little helper tool that makes it really easy to work with MongoDB in a development environment. So I'll see you in just a second. Now that we've got Mongo installed on our Windows operating system, we're going to install a second companion tool for working with MongoDB. This program is called RoboMongo, and it is used to look at all the data that is sitting inside of our Mongo database. In essence, it's a nice fancy GUI or graphical user interface for looking at everything that's sitting inside of our database. So let's get it installed and see how it works. At my browser, I'm going to navigate to robomongo.org. Once here, I can either find the download button on the bottom left or top right hand side. So let's click on download. I'll find the latest version and then click on the download link here. And then I can select either the installer or portable version. The installer right here will install RoboMongo and it automatically give you some links in your start menu and nice stuff like that for opening it in the future. If you don't want to install it, you can grab the portable version, which will give you just the installation directory by itself, and then you can run the portable version at any point you like. I think I'm going to go with the portable version because I usually prefer minimizing the amount of stuff that I have installed on my operating system. So I'm going to download the portable version. This grabs a zip file. After it's done downloading, I'll open up the zip file. And then inside of here, this is where everything we need for running this RoboMongo tool sits inside this folder. I need to extract this to some location on my machine. So I'm going to open up a file explorer. I'll open up my desktop and I'm going to extract everything inside of this folder to my desktop. Now once it's extracted, I'll open up that folder. I'll find my robomongo.exe file inside of here and run it. Okay, by default, I've got a single connection here. Very likely you do not. So I'm going to delete this connection and we'll start over from scratch. So I'm going to click on Create to create a new connection to the local database that we just set up. The default address and port in here are A-OK. If you want to change the name, it's totally up to you, but the name isn't actually used for anything. So I just need to click Save. Then I can select this new connection and click Connect. Now, if you have any difficulty with connecting to this instance, you might try restarting your Mongo server. So I've got my running Mongo process over here. I can stop it by hitting Control-C. And you'll notice that now it exits the Mongo executable. I can then start the process back up and we'll try doing connection again. And there we go. That time everything worked out just fine. So right now I have absolutely no data sitting inside of my Mongo database, and so I have nothing in here to select. However, as we start to make use of Mongo and we start to add some data in, we're going to see some different data or different pieces of data sitting inside of this new connection object right here. So this is all we have to do for right now. We're going to continue in the next section. We're going to talk about how Mongo works, and then once we start inserting data into our database, we'll come back to RoboMongo and just observe that data sitting inside there. So let's continue in the next section. Now that we've got Mongo set up, we're ready to move on to working with some code. The first thing that we're going to talk about is a little bit of a precursor topic to working on anything really very specific on Mongo. The topic that we're going to talk about is a little bit of ES6 review, specifically around promises. Promises are extremely important to have a very good solid grasp of whenever working with Mongo, because promises represent the number one way in which we will interact with the Mongo database. So in this section, we're going to do a little bit of a review on promises just to make sure that we're both on the same page around their syntax and exactly how they work. To do so, we're going to make a tiny little game out of an HTML document. And inside that game, we'll kind of experiment around promises a little bit and just get a good sense of how they're put together. Okay, so that's our goal. I know that I said we are going to put together an HTML game. Yes, this is of course all about working with servers and databases and stuff like that. But it just so happens that making something inside of a web browser like an HTML document really helps to reinforce exactly how promises work. So let's get started. The first thing we're going to do is go to a convenient workspace directory on my desktop. So I'm inside this directory called promises. Totally a-okay place to make a new file where we can experiment around with it. Once I'm here, I'm going to open up my code editor inside this directory. So for me, I have the Atom code editor installed. Because I have that installed, I'm able to run atom dot right here. If you are not using Atom, or if you're using any other type of code editor, totally a-okay, totally fine. You're going to be just fine throughout this entire course. All you have to do right now is just start up your code editor. Once I have my code editor open, I'm going to make a new file inside of this directory, and I'm going to call it index.html. Again, all we're going to do inside of here is write a little bit of HTML and JavaScript code to experiment a little bit with promises. Now inside this new file that I just created, I'm going to create a head tag, a body tag, and then inside the body tag, I'll add a button that says click. And then inside of a script tag, a little bit lower, I'm going to add in a console log of game is starting. Okay, so we've got just a raw HTML document right now. I'm going to open up this document and make sure that it all works inside of my browser. So I'm going to open up the HTML document. That opens up a new Chrome tab. I've got a click button very prominently displayed right there. I'm going to zoom in a whole bunch just to make sure it's nice and legible. And I'm also going to open up my terminal as well. You can open up the Chrome console by right-clicking anywhere and clicking on the Inspect button on here, so the Inspect option. And then you can select the Console tab on here, and I should see now game is starting on the right-hand side. Okay, so I'm sure that right now you're sitting here thinking, Stephen, how is this going to lead to promises? Well, I guarantee you it is. Let's take a quick break now that we've done a little bit of setup here. Come back in the next section and talk about exactly how we're going to make a game using promises. So I'll see you in just a second. In the last section, we put together an HTML document with which we're going to figure out a little bit more about how promises work. Even if you're familiar with promises, I still recommend you go through this section just to make sure you have a quick refresher. So we put together this HTML document with the thought being that we're going to make a tiny little game to figure out how promises work. I'm going to flip over to my code. As you can see right now, we've got just our button and just the script tag. So here's the plan. In this section, we're going to write our game. We're going to put it all together, and we'll talk about exactly what the game is in just a moment. We're going to put the game together using nothing but vanilla ES5 JavaScript. So no promises, nothing like that whatsoever. So we're going to do that inside of this section. And then in the next section, we'll come back, we'll talk about what promises are, and then we will refactor the code that we're going to write to use promises instead of just vanilla ES5 JavaScript. And we'll kind of do a little bit of comparison and contrasting and just make sure that we've got a really solid grasp on what's going on. So let's talk about what this game is that we're going to be making. I'm going to pull up a diagram really quick. Okay, so this is pretty much it. Well, the button is all the game there really is. So we've really already got all the UI or display elements for the game that we're going to make. And then on the right-hand side, you can see a little bit of diagram of how this game is going to work. Whenever the user refreshes the HTML document, so I mean like press F5 on your keyboard or Command R if you're on OS X, we're going to start our game, so to speak. The goal of the game is to get our user to click that button at least 6 times. If the user clicks the button in at least 6 times in 2 seconds, which is when the game ends, they've got 2 seconds to click it 6 times, we'll then ask the question, hey, did the user click that button enough? If they clicked it at least 6 times, we say, yep, they won. If they clicked it less than 6, then sorry, but you lost out. You can always refresh the document and try again. So this is our game. We're going to write it with some ES5 code. We'll refactor it in the next section to use promises, and we'll figure out exactly how these things work. So let's get started. I'm inside my code editor, and the first thing I'm going to do is I'm going to take out this console log because we just, really not doing a whole lot for us just yet. To make our game, we're going to break it down into 2 separate steps. First, we'll add in a little bit of logic to watch for the button to be clicked. Whenever the button is clicked, we'll increment a counter variable by 1. Then the second part of our code, we'll wait for 2 seconds, and then after 2 seconds, it'll look at this counter variable. And if it's greater than 5, then the user won, otherwise they must have lost. Okay, so 2 steps, 2-step process. Let's get to it. I'll first declare a counter variable and start it off at 0. Because I expect the counter variable to change over time, I'm going to use the let keyword to declare it. So this is a little bit of ES6 code that we're going to see sprinkled throughout this entire course. Now we need to watch the button element, and anytime it gets clicked, we will increment this counter variable by 1. So again, we're not using jQuery here, we're not using React or Angular, we're using just vanilla JavaScript. To set up a click event handler on a normal HTML element, we can say document.querySelector. We'll find the first button tag in the HTML document, and then we will add an event listener to it. And specifically, we're going to listen for the click event. Then whenever a user clicks on this button, we will run this function that we'll pass in as the second argument. So whenever a user clicks on the button, we will take our counter variable and increment it by 1. So I'll say plus plus counter, like so. So that's step 1. We're watching for that button. Anytime it's clicked, we'll increment the counter by 1. Now the second step is to wait 2 seconds and then look at the counter variable. So to wait 2 seconds, we'll use the built-in setTimeout function. The first element or first argument to setTimeout is a function. So I'm going to pass one in. Here it is right here. And then the second argument is the number of milliseconds that we want to wait before we execute this function. So I'm going to say that I want to wait 2000 milliseconds, which is 2 seconds really. Now inside this function, we'll say if counter is greater than 5, we will alert to the user, you won. Otherwise, we will alert, sorry, you lost. And that's pretty much it. So let's give this a test out in the browser and just make sure that the game by itself is working. Then we'll take a quick break, come back, and refactor this code that we have to work with promises as well. So I'm going to change back over to the browser. So I'm going to refresh the page. Then the instant I do, I need to click this button at least 6 times to win the game. So let me give it a shot. I'll refresh. 1, 2, 3, 4, 5, 6. Okay, well, I'm not supposed to lose. I'm supposed to win. So let's do this for real. All right, here we go. All right, I won. Fantastic. Just out of curiosity, let's tell the user how many times they clicked. We'll say on the alert string, you won your clicks. And then we will add on counter like so. We'll have a little bit of a contest here. Maybe you can click more than me. All right, I'm gonna click. Okay, 12. Yeah, that's pretty respectable. The highest I ever got was like around 16. If you can get more than 16, you definitely beat me. So let me know if you can get more than 16. I'll be very impressed. Keep in mind that I'm using a OS X or a Mac trackpad, so maybe if you have an actual mouse, you might be able to do a little bit better. Anyways, totally off topic here. So clearly our game is working, right? Everything's working here, but I want you to look carefully at the code that we have right now. Right now, the way that everything is written, to handle the case in which a user wins or loses, we have to stuff a ton of logic directly into this setTimeout function right here, right? Like if the user wins, we have to handle that logic like right here, this very line of code. And if they lose, we have to handle it right here on this line of code. And so you might look at this and say, Stephen, of course you have to handle it here. Where else would you handle it? What's the problem with this? Well, what I'm suggesting is it would be really nice if maybe we could wrap up our entire game as a standalone library of sorts, right? So maybe I could publish this as a reusable package or something like that so that other developers in the world could make use of my game in a really nice fashion. So maybe all they would ever have to do is call a function called start game. And then maybe once they call start game, they had some really nice interface to write some logic to handle whenever a user wins or loses. So what I'm trying to say here is that the code we have looks good, but perhaps we can do better than this. Okay, perhaps we can do better. So let's continue in the next section, and we're going to figure out exactly how we're going to use a promise to rewrite our code to look a little bit nicer. Okay, so I'll see you in the next section, and we're going to figure that out. We've now got our simple little HTML game put together. If a user clicks on the button more than 5 times, then we consider them to have won. Otherwise, they lost. So the game definitely works as it stands right now, but I started to make the case at the end of the last section that perhaps the way in which we wrote this game wasn't the best in the world. I threw out the case in which we might want to let some other developer run this game, right? Well, we might want to publish this thing as a function or as a standalone package. So another developer could run the game, and then we would need to allow them to specify what to do whenever the user successfully completed or failed the game. So thinking about this in from a diagram standpoint, this is what I'm kind of suggesting. I'm saying that I want to have the exact same game experience, but I want to wrap up all that game logic into a single function, which is represented by this kind of blue or cyan background. I then want to allow another developer to come in, start the game up, and specify exactly what should happen if the user succeeds in the game or they fail in the game. So in other words, I want to refactor our current code base, everything that represents this game, into a single function that can be called, where another developer can specify what to do after the game is played. So let's do this refactor, and then as we go, we're going to introduce the topic of promises and figure out how they work. So I'm going to flip back over to my code, and just to start, we're going to do a little bit of a refactor to first put our entire game into a standalone function. So at the very top, underneath the script tag, I'm going to declare a function called startGame. I'm going to place an opening curly brace. Then I'm going to take all of my game logic. I'm going to indent it one time, and I'm going to close off that curly brace down here at the bottom. So now my entire game is wrapped up inside of this startGame function. So now I've kind of succeeded in putting all of my game logic into a standalone function, but that standalone function still encapsulates what to do in the success and fail case. Just to make sure that everything still works appropriately, I'm going to add in a call to start game underneath the function declaration. So down here, I'll call start game like so. And now back inside of Chrome, we're going to refresh the document and make sure everything still works. So here we are. I'll refresh. I'm just going to wait the 2 seconds. And okay, everything for the game still works as I would expect. So our code as it stands right now, again, still works, but we're not providing a nice interface to any other developer who wants to call start game. That's the whole goal here. I want to somehow specify what to do when the user wins whenever I call start game. So to do so, we're going to introduce the idea of promises. Now, promises I have explained to developers many, many times, and through every single time that I have explained exactly how promises behave, I have discovered exactly one thing. Telling you how they work does not impart knowledge about promises. In other words, I can sit here and lecture all day about what a promise does, but it doesn't quite translate. You really got to see these things in action. So here's what we're going to do. Rather than have me sit here and spout off about promises nonstop, we're just going to refactor our code to make use of a promise, And then once we've got it in place, we'll make some observations about exactly how it works, okay? So we're gonna do the refactor first. It's gonna be a little bit mysterious, but then we'll talk about exactly how it's working. So to refactor our code to use promises, I'm going to start off by deleting the entire inner set timeout statement. And the only reason I'm deleting it is because I want to write this thing from scratch to make sure it's really clear to you exactly what's going on. So in place of that set timeout, I'm going to write return new promise, and note that I'm using a capital P here. I'm then going to pass this promise function, or this promise thing, whatever it is right here, a fat arrow function. Okay, so I just passed it a fat arrow function like so. Whenever I declare a new promise, this inner function that I pass to it is called with two arguments, resolve and reject. Now inside of here, I'm going to place the exact same or nearly exact same logic we had before with the set timeout. I'll say set timeout. I'm going to pass it a arrow function. As a second argument, I'll say 2000 milliseconds. Then inside of the set timeout, we can say if counter is greater than 5. And here's where things get interesting. Instead of saying anything about alerting or anything like that, I'm going to look at this argument, this resolve argument, and I'm going to call it. Okay, again, I know I'm throwing up a ton of code that's looking a little bit mysterious, but bear with me. We're going to finish the implementation here and then talk about exactly what's happening. So now on the else statement, so this is the case in which a user fails, I'm going to add on a call to reject. Now one last little bit. Down here at the bottom where I call start game, I'm going to remove the semicolon at the end, and instead I'm going to replace it with, on a new line, .then. I'm going to pass .then a function, inside of which I will alert you win. And then one last thing, bear with me. At the very bottom, after that, I'm going to add on a catch and I'll alert you lost. Okay, so a lot of changes we just made, and chances are a lot of it looks a little bit weird. Totally fine, totally what I expect. Let's first run this inside of our browser and verify that everything works, and then we'll talk about exactly what's happening here. So I'm going to make sure that I first save the document, so everything's saved. I'm going to flip back over to Chrome. I'll refresh the document. I'll click the button. Well, I guess I didn't click it enough because I saw you lost. Let's get a winning case in here. I'll click, and you win. Remember that to restart the game, you need to refresh the browser. So I'm going to refresh, click, and I win. Okay, so clearly something's working here, right? Clearly something's working still. But what the heck is this promise thing? What's this resolve and reject? What's this .then and .catch at the bottom? Let's take a quick break. We're going to come back, talk about exactly how promises work, and then we'll be all done with the refresher on promises. So just one more section, and we'll be all wrapped up with our refresh. Okay, see you in 1 second. In the last section, we refactored our project a little bit to make use of a promise. We're now going to continue by talking about exactly what a promise is and how we used it inside this project. So first off, a plain English definition of a promise. A promise is a tool that we have for managing asynchronous code flow throughout our application. And so once I say that, gee, that doesn't sound very plain English, does it? Essentially, a promise is a tool for handling any code that is going to execute at some point in the future. And that's exactly what's happening with the set timeout. We are saying execute this logic right here 2 seconds in the future. So at any point in time where you have some amount of code that's going to execute at some amount of time in the future, you want to be thinking promises. And this is highly relevant for working with databases for reasons that you'll see in just a little bit. Anyways, back to promises. When we create a promise by using this new promise structure right here, we pass in a function. The function right here is called with the resolve and reject keywords. And so resolve and reject, excuse me, I said keywords, I meant to say functions. The resolve and reject functions. The resolve and reject functions allow us to manipulate the state that a promise is in. And so that last part is probably the most important part about promises. Let's talk about exactly what I mean by state that a promise is in. By default, a promise has three different possible states. We will refer to it either as being unresolved, resolved, or rejected. When a promise is unresolved, it means that we're just kind of waiting around, twiddling our thumbs, waiting for something to finish. And so this is exactly the case when we are waiting for our user to click on the button. During those 2 seconds where the user has the opportunity to click on the button a whole bunch, our promise is in the unresolved state. It means we're waiting for the user to finish up all their possible clicks. After those 2 seconds, the promise enters either the resolved or rejected state. When a promise is resolved, it means, hey, the operation finished. Like whatever long-running operation that was, it ran, everything went A-OK. Everybody was all happy about it. Alternatively, a promise can be rejected. Rejected means something didn't quite go quite so well. In the context of our game, we consider the promise to be resolved if the user successfully clicked on the button at least 6 times. And we consider it to be rejected if they didn't click on it 6 times. The important thing to note here is that it's really up to us, the developer, to decide what constitutes a resolved or rejected promise. So I decided to say that if a user lost the game, something went wrong, and I wanted to reject that promise. And I decided to say that if the user won and they clicked on enough, then I resolved the promise, meaning to say everything went A-OK, the user won the game. We can change the state of the promise by calling either the resolve or reject functions that are passed to the promise itself. If we call resolve, the promise enters the, as you might guess, resolve state, and if we call reject, it enters the rejected state, which is rejected right here. Once we either resolve or reject the promise, any callbacks that we add to the promise are then called. So note that when I called start game right here, I chained on a .then and then a .catch. The first thing to take note of here is that when I called start game, it returned the promise that was created. So when I add on the .then and the .catch, those are being added onto this new promise that I created right here. When I resolve the promise, any function that I pass to .then will be called. And when I reject the promise, any function I pass to .catch will be called. Because my promise can only ever be either resolved or rejected, we know that only the functions that we pass to .then or the function I pass to .catch will be called, never both. It's always one or the other. When a promise is resolved or rejected, it enters that state and that is it. It will never ever change again. So once you resolve or reject it, that's all you get. Now the last thing I want to tell you about promises is that I've shown you kind of the entire big picture of them, both how to create a promise with this new promise keyword up here and this resolve and reject thing, and how to make use of it by adding on the .then and the .catch. The important thing to keep in mind here is that the absolute vast majority of libraries that you will use that make use of promises, and I'm talking about like jQuery or Axios or Mongoose, which we'll be using inside this course, do not require you to implement this side of the promise, the actual like promise creation side. As a developer, it is much more common for you to make use of the consuming side of the promise, where you will chain on the case to handle the success of the promise or the error of the promise. So if this code up here looks a little bit crazy, hey, don't sweat it. You're not going to be seeing this side of things too often, if ever, really. It's much more common that you'll be working on this side of the equation, where you make some call to a function, and then it's up to you to chain on some logic to add on for handling the success or the failure of that operation. Okay, so again, this is just a little bit of an overview of promises. It's just intended to be a little bit of a refresher. As we use promises throughout this course, you're going to see an incredible number of different implementations of them. Like every single section we go through is going to make a promise. So even if this looks a little bit mysterious right now, you know exactly what's going on, hey, don't sweat it. You're going to get so much practice with promises that you're going to be absolutely sick of them by the time this course is over. Okay, so now that we've gone over promises, let's continue the next section and start getting a handle on MongoDB. Now that we've finished our preliminary setup with Mongo, we can start to ask some of the real questions about the database, like where do we use it? How does it fit into a modern web stack? After we start to answer some of these questions, we'll then focus on some of the fundamentals behind Mongo as well. After that, we'll get started with our first project. One thing that's really important to me in every tutorial that I write is to make sure that you start writing code as soon as possible. So we're only going to do a little bit of preliminary discussion around Mongo, just enough to kind of get you familiar with it, and then we're going to dive immediately into our first project. So let's get started with figuring out where we use Mongo. Mongo is a database. It is intended to store data that needs to be persisted inside of any application. So this could be data like our users' email addresses, or recipes, or to-do lists. Any type of data like that we need to persist inside our app. Mongo will traditionally be separated from the outside world, and when I say outside world, I mean the wide internet, by a web server of some type. In this case, I've reflected a Node server. Mongo does not have a dependency on Node, however. We can use it just as well with a Ruby server, Python, Java, C#, whatever you can possibly imagine. There's about a dozen different languages that have fantastic support for working with Mongo. Traditionally, we'll put this web server in between our browser and any mobile apps that we might have, so that any request for data will be filtered by this web server before it hits our database. Traditionally, we enforce security around our data with rules that we'll place inside our web server. So, for example, if a user in our browser application tries to save or destroy a record, we'll make sure inside of our web server that the user has permission to actually make that change. And then only after we've made that check do we allow the request to modify our database in some fashion. You'll notice that I've reflected on here this extra square, something called Mongoose. Mongoose is a ORM or ODM, ORM being Object Relational Mapper, or sometimes referred to it as ODM, an Object Data Mapping. These are really just fancy terms, to be honest, to say something that helps you work with your database better. That's the plain English definition. Mongoose is something that allows us to work with our Mongo database in a much easier fashion than if we were using our core Mongo APIs. We will sometimes work directly with Mongo, but for the most part, we'll be working with Mongoose just because it is without a doubt the industry standard. And I want to make sure that you learn industry standard for everything having to do with Mongo. Okay, so a little bit of background on Mongo itself. Let's continue in the next section and dive into a little bit of the terminology around Mongo and try to learn a little bit of the fundamentals as well. So let's take a quick break and I'll see you in the next section. In the last section, we had a little bit of a discussion about where Mongo fits into a modern application stack. I want to specifically mention where it fits into the modern application stack because I do get a lot of questions about, hey, how do I connect my browser application or my mobile application directly to my Mongo database? And the answer is that, well, you don't really connect those directly to your database. You usually have a web server in between there. So hopefully that's a little bit more clear now. We're going to continue by talking a little bit about the fundamentals of Mongo. Mongo bases all of its data storage around two different faucets or two different ideas. First off, Mongo allows us to have multiple internal databases inside of a single Mongo instance. So a little bit ago, we installed Mongo onto our local development machine. And we were able to confirm using RoboMongo that, yep, a database does exist. We just made one, something's there. However, after we install Mongo, like that running process, that thing that we start up on our machine, we have the option to create multiple databases within this single Mongo instance. The purpose of this is to allow us to work on multiple different projects without having to dump all of our data. So the idea here is that maybe today I'm going to work on some project focused on working with some amount of data about states and books. And tomorrow I want to focus on a project where I'm working with movies and images. Rather than having to dump our entire database and all the data that's sitting in there, Mongo allows us to create multiple databases inside of one Mongo instance. It is important to note that we usually will not use multiple databases in a single application. This is much more about allowing us to develop on multiple applications without having to do a lot of fancy setup. The reason I mention this is because it introduces a little bit of confusing terminology. We refer to Mongo as our database, but we're also going to refer to each of these instances as databases as well. And so I'll try to be very clear about my terminology as I say or refer to database, but in general, you can assume that I'm talking about a distinct bucket for all the data in our application. Now back to what's sitting inside of this database, these two things right here, these two white boxes. Inside this diagram, I have reflected a collection of states and a collection of books. The collection is the core unit of what stores data inside of a Mongo database. We'll traditionally have one collection for each type of resource that we might need to make available in our application. So for example, if I'm making an app about states and books, I will have a collection of states and a collection of books. We will not mix any type of data inside of our collection. So in other words, it wouldn't really make any sense for me to take a state and put that state into my collection of books, right? It's a state, it's not a book, so I would not put it into my books collection. As such, we will usually, ahead of time, whenever we're developing any type of application, we'll try to picture in our heads, or we'll come up with some schema or design of the different types of data we'll need to store inside our app. So if I'm making an application where I want users to memorize a list of states, I would probably sit down ahead of time and think to myself, okay, well, I want to make an application that contains a list of states, therefore I should probably make a collection of states. In general, collections are a really great thing to think of and make some good solid design decisions ahead of time, rather than getting halfway through your development process and realizing, oh, well, I actually want a collection of counties rather than states. But I think you get the idea. We're going to continue in the next section and talk a little bit more about the core of Mongo and Mongoose, and then start diving directly into our first application. So let's take a quick break and then come back to this diagram. I'll see you in just a second. In the last section, we had a discussion about two of the core principles of a Mongo database. And when I say Mongo database, in this case, I'm talking about the overall Mongo instance. First, a single Mongo database can have multiple internal databases. Second, inside of each of these databases, we can have multiple collections. Each collection represents a single type of resource, and it's extremely uncommon for us to ever have any reason to mix different types of data inside each of these collections. So the example we gave was that I would probably never take a state and put it into my collection of books. We then left off with this little diagram right here that's going to lead us into the first project that we're going to work on. In this first project, we're going to get some mastery over the absolute core ideas behind Mongoose and Mongo. So remember, Mongoose is a library that we're going to use to give us a very nice and elegant API to work with Mongo. So in this section, it's all about mastery of core concepts. The core concepts of Mongoose and Mongo are these four operations I've listed on the screen. We want to make sure that we know really darn well how to create data inside our database, how to read data out of the database once it's in there, how to update the data once it's in there, and then how to destroy or delete data inside our database after we've placed it there. So this first project that we're going to work on is all about these four core operations. Colloquially referred to these four operations as CRUD, or C for create, R for read, U for update, and D for destroy. A lot of people, I say CRUD frequently, and people think that I'm like cursing or something like that. No, it's referring to create, read, update, destroy. That's where CRUD comes from. So we will talk about the purposes of this project that we're going to work on in just a moment. But for right now, I want to do just a little touch of setup. And then next section, we'll come back and talk more about what we're doing. So let's get to it. I'm going to open up my command line. So here I am. And I'm inside of a directory where I can locate some number of projects. So it might be like a workspace directory of some type for you. For me, I call this prod because this is the production version of all the code that I'm writing for this course. That's why I call this folder prod. Inside this directory, I'm going to make a new file called users, and then I'm going to change into that directory. Now this directory is completely empty right now, so nothing in here just yet. For this first project, we are going to make a tiny little application from scratch just for the purposes of learning more about the Mongo and Mongoose API. This is not really going to have any outwards facing visual component. It's going to be entirely about going through a number of exercises and figuring out how Mongoose and Mongo really work. I'm really excited about this project, even though it might sound like a little bit boring, because we're going to set up everything for this thing from absolute scratch. So you are going to really know how to wire up a application from scratch with both Mongoose and Mongo. All right, let's take a quick break, come back, and then get started on the setup of this application and talk about exactly what it is we're going to be making. In the last section, we created a new project directory to house the project that we're going to be working on. We're going to do just a touch more setup right now, and then we'll talk about exactly what it is that we're going to be making. First, at my command line, I'm going to run the command npm init. This will generate a package.json inside of my current directory right here. Package.json is a file that is used to record dependencies that will be required for this project that we're going to make. Like I said, we're doing this whole thing from scratch, and step number one is always to start a new package.json file inside your project directory. So I just ran npm init, and now I'm going to be prompted with a series of questions. We're not going to enter any important or information just yet. We're going to come back and change these settings later on. So for right now, I'm just going to press enter, 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 and that's it. We're good to go. Now I'm going to install 3 different packages into this project as well by using the npm package manager as well. So I will run npm install -- save, and then 3 different packages. The first one is going to be Mocha. The second one is going to be NodeMon. And the third one is going to be the Mongoose library that we've been discussing. So I'll say Mongoose like so. Do double check your spelling on all 3 of these. We definitely want to make sure you're getting the correct packages here. All right, so we'll let that go. It's going to take just a moment to install. So while that is running, let's talk a little bit about the application that we're going to make. So here's the goal. Remember, the whole point of this first exercise is to make sure that you get total mastery of the very 4 common fundamental operations in a Mongo database: creating, reading, updating, and destroying data. To make sure that you've got total mastery over these concepts, we're going to wire up a simple application. Again, it's going to have no front end or UI component or anything like that, where we will create a Mongo database with a collection of users. And a user is going to be an object of some sort that has maybe a name and an email address, that kind of stuff. We're then going to wire up this collection of users to the Mongoose library. And then once we wire these 2 things up together, we're going to use the Mocha testing framework to test our entire setup and make sure that we are actually inserting records into our database. Now, this might sound like kind of a goofy first project. You might be thinking, Steven, this is so simple. Why can't we do some fancy web application with HTML and JavaScript and animations and cool stuff like that? Hey, I'm totally with you. Totally with you. I want to make the cool stuff too. But before we get to the cool stuff, we got to make sure that we got those solid fundamentals. And trust me, as we go through this process, all the code that we write with Mocha, all the testing stuff that we do, is going to be 100% applicable to your production style applications. And what I mean by that is, as you go and work on your own projects, if you want to come back and write some number of tests in there as well, you will be able to take the exact same principles and concepts that we're going to use with Mocha and Mongoose and apply them there as well. So really, I'm very excited about this project. I think there's going to be a lot of very good value you get out of it, and I think you're really going to like it. So let's check our install status. Okay, looks like everything's good to go. I want to cover just one more quick topic before we start writing some code in the next section, and that is to talk a little bit about our project structure. So here's a diagram of all the different files that I expect to have inside of our project. We're going to create one folder called src, which is just short for source, and it's going to contain a file called user.js. This user.js file is going to contain a bunch of code that somehow maps Mongoose and Mongo together. Okay, so that's where we're going to kind of put these 2 ideas or these 2 concepts together. Once we put together this user.js file, we'll also start to write some test files in a separate directory called test. we're going to have 4 separate files in there, one for each of the most common ways that we'll manipulate a resource. So we'll have a single file to test our ability to create a new user and save it to the database. We'll make another one to read some data out of the database, and then update and destroy as well. I think you get the picture. So as we put together this model, we'll be testing all the different common operations that we'll want to use on it inside of our test directory. At the end of the day, again, we're going to have a great idea of how Mongoose and Mongo work together. So I'm really excited about this project. Let's get started with our coding in the next section. In the last section, we spoke a little bit about our first project. We're going to use the Mongoose library to modify our database in some fashion, and then we'll use the Mocha testing framework to make sure that those changes actually took place and that we did the right thing. We're going to use the Mocha testing framework to test out the 4 most common operations that we'll use whenever working with our Mongo database: creating data, reading it, updating it, and destroying it. Just to be really clear, the Mocha test framework right here is by far the most popular framework for doing any type of JavaScript testing around the Node.js environment. So if you don't have previous experience with Mocha, don't sweat it. We're going to walk through it step by step. Even if you do have previous experience with it, I think that maybe you'll appreciate seeing a little bit of the intricate setup that we're going to do with Mocha as well. We also spoke a little bit about our project directory structure. So we're going to have the source file and the test file, or excuse me, source directory and test directory. Let's open up our code editors and create those 2 folders now and get started on this. So inside of my terminal, I'm going to open up my code editor. I use Atom personally. If you use any other different type of editor, be it VS Code or Sublime, whatever you like to use, no problem whatsoever. You'll do just A-OK. The instant I open up my test or my project directory, you'll see that I've got one folder in here already called Node Modules. This folder contains the dependencies that we just installed in the last section. Remember, we installed Mocha, Mongoose, and NodeMon at the command line. One other thing about NodeMon, we'll talk about its purpose in just a moment, but it's something that's going to really help us out when we are running our tests. So we'll come back to NodeMon in a moment. Okay, so in our users directory, I'm going to create a new folder called src, and then another new folder called test. Now inside of test, we're going to start off with doing a list of our test environment setup. So in here, I'm going to make a new file called test_helper.js. Inside of this file, it's customary to place any code that we might need to have to set up our testing environment. And it's certainly customary to call it a name such as test helper. So inside of here, we'll do some initial setup for our tests. Now you might be thinking, Stephen, what possible setup could we have to do? Like, what is there to do? Well, that's a good question, one that I'll answer right now. We're going to look at a diagram that's going to kind of give us a handle into figuring out exactly how our code is going to execute when we run a command to test our project. When we run a command to test our project, all of our code will be loaded up and the Mocha library will start up. And it'll say, okay, I guess it's my show. I'm running right now and I need to run some tests for this user so they'll see if their code works or not. And that's going to be our time to run some tests and make sure that we're modifying our database correctly. But before any of that happens, there's a couple of steps in here that we have to get to. First, Mongoose is a JavaScript package. It's just a chunk of JavaScript. There's not really any special behavior about it. In order for Mongoose to work with Mongo, we have to initiate a connection. So there's nothing about Mongoose that's going to automatically say, you have a Mongo database running on your machine. I guess I'll just connect to it. It doesn't do that. We have to explicitly tell Mongoose to connect to our instance of Mongo. Telling Mongoose to connect to Mongo takes some amount of time. It's not like an instantaneous process. We don't just say, hey, connect to this thing, and boom, it just happens. Instead, we have to wait some, arbitrary amount of time. We don't really know how long it's going to take. But the point here is that inside of our test helper file, we're going to do a little bit of setup code to tell Mongoose to connect to Mongo. And then once Mongoose connects, we're going to check to see if the connection was successful. If it was, we'll go ahead and run our tests. Otherwise, if the connection failed, we'll show an error and stop our tests from running. So that's our plan. This is our goal. This is the initial setup we're going to do inside of the test helper file. Now there is another little bit of setup that we're going to do in there as well, but we'll get to that in just a moment. Let's focus on just this little bit of connect logic first. All right, so I'm going to flip back over to my code editor. And inside of here, we're going to write a little bit of code, and then we're going to talk about what it's doing. I'm definitely a huge fan, well, a very big fan, I should say, of making sure that it's really clear exactly what we're putting on the screen. You know, you're never going to really catch me copy pasting from somewhere else and just tossing it up there and telling you to do the same. Sometimes, however, it's really nice to just toss some code up and then take a quick pause and then talk about what it is, as opposed to kind of leading into it in a nice way. So this is one of the times where we're going to put a little bit of code on the screen, and then we're going to walk through it line by line and discuss exactly what's going on. Okay, so we're going to do a little bit of typing and then talk about what's happening. At the top, we'll start off by writing a const, and we'll say const mongoose equals require mongoose. Now already I just feel myself wanting to tell you exactly what's going on with this line of code, but I'm going to stop myself. Really, this is a lot of self-control I'm exercising right now, just so you know. We're just going to keep going, and we're going to come back to this line. Next, I'm going to say mongoose.connect, and I'm going to pass in a very special string to this function right here. I'm going to say MongoDB : //localhost /users_test. I'm also going to close my sidebar so you can easily see everything. And I'm going to end this line with a semicolon. Next, I'm going to say mongoose.connection. And then we're going to add on two little statements to this thing. So I did not put a semicolon at the end of this line. I'm going to say once open. I'm going to add in a fat arrow function, and I'll console log out of here, good to go. And I'm going to add on another statement, a .on air as a string as the first argument, and the second argument will be another fat arrow function that will be called with an air argument. And then inside of here, we'll say console.warn, and I'm going to pass in the string of air and then air, like so. Just to be clear on this last line inside of here, I said console.warn. The first argument was a string of air, and the second argument was the air variable that this function was called with. So I know there's a lot of words air in here floating around. How about this? Let's change air right here to just warning. Let's be clear. The other thing I want to point out to you is that there's no semicolon on either lines 4 or 5. The semicolon for this entire statement that starts on line 4 is down here on line 8. Okay, so, that was painful to type so much stuff without having me telling you what the heck's going on here. Let's take a quick break, and then we're going to come right back, and we're just going to dissect the heck out of this chunk of code. So one quick pause, I'll be right back and talk about this thing. In the last section, we threw a ton of code on the screen without really saying what the heck was going on. So this is our chance. This is where we're going to rewind just a little bit and talk about all the code that we just threw up here. So first we'll start off with line number 1. On the right hand side of the equal sign, we put require mongoose. In case you're not familiar with Node, hey, no problem if you're not. This is how we do code sharing between different files in a Node environment. We installed Mongoose as a package to our project. By default, every single file in our Node project is executed in its own little scope, or it's executed in isolation. So just because we installed a package called Mongoose doesn't mean that we can just start saying, oh, hey, Mongoose, Mongoose, Mongoose all over the place and just start making use of it. Before we can make use of any package we install, we have to require it into this particular file. So by requiring in the Mongoose library, we assign it to the variable Mongoose right here. To the left-hand side of Mongoose, we're using the const keyword, which is a little bit of ES6 code. Throughout this entire course, we're going to follow ES6 as closely as possible. I will throw in some descriptions or clarifications, reminders about how ES6 as we go through it. The const keyword in particular is identical to var. Well, I shouldn't say identical, but it's very similar to var. We use it to declare variables. So it would be equivalent to saying var mongoose const mongoose is the same thing. Const in particular means that we don't expect to be making any changes to this variable, which is definitely true because it is a library, and I'm sure as heck not going to be changing a library. Okay, line 1, down. Next up is line number 3. So this is where things start to get a little bit of interesting with Mongoose, and it ties back into the diagram that we were just looking at. When Mocha first starts up, our goal is to tell Mongoose to connect to Mongo, our actual Mongo database that is running on our local machine. We initiate this connection by using Mongoose's connect function, so mongoose.connect. Then the argument to this thing is what's really important. This is the important part right here. Mongoose does not assume that you want to connect to a database that is running on your local machine. In fact, it doesn't even try to see if there is an instance of Mongo running on your local machine. Instead, Mongo requires you to tell it explicitly, very directly, what copy or what server of Mongo you are trying to connect to is. So this localhost variable, or this localhost part of the string right here, means on my present machine, try to find a Mongo database. If we were using some remote Mongo data store, or excuse me, a remote Mongo database that is hosted on some remote server, we could type in directly the port in here. So like maybe 6565, something like that. And then we would specify the port that the server or the Mongo instance was running on. So like maybe port 4000. In this case, our Mongo server is running locally, however. So all we do is say connect to the Mongo instance running on my local machine. There you go. And Mongoose kind of takes it away from there. Everything after that slash, this user's test, is another important little piece of the puzzle right here. Remember that when we were talking about Mongo earlier with some of these diagrams, I had said, oh yeah, you've got your Mongo instance, but in that instance, there's like multiple databases in there, right? Like we discussed that a little bit. That's what this last part of the string is right here. If we have multiple databases in our MongoDB instance, Mongoose is going to ensure that it connects to a database called users_test. So if I went back to this diagram and I modified this thing to kind of match up with our situation right now, we would have something that looks like this. So at this point, when we connect to Mongo, we're telling it, hey, connect to this thing called the users test, and any collections of data that we create, store them inside of that database. Note that we do not have to create a database ahead of time to be able to access it. As soon as we try to connect to this database and then save a record to it, Mongoose and Mongo are going to work together to ensure that that database is created automatically for you. So again, you don't have to create this stuff ahead of time. You can just kind of say, oh yeah, I assume this thing is here. Just go for it. Just make it happen. And Mongo will take care of everything else for us, which is really nice. Whew, line 3, almost there. Just a little bit left. So line number 4 now. Going back to our diagram of showing the kind of series of events when we start up our testing stuff, I'd said that we tell Mongoose to connect to Mongo, and then we wait for some who knows period of time, right? We don't know how long it's going to take for Mongo to connect to Mongoose. This might be a Mongo database that is like off in Europe. That is a relevant comparison for me because I'm located in the United States. What I'm trying to say by that is this could be a Mongo database that is sitting on the other side of the planet. And so we don't know how long it's going to take Mongoose to connect to it. In order to get a message back to us only when the connection has succeeded or failed, we use this once and on event handlers right here. These are both event handlers. Once means watch for Mongoose to emit an event called open one time, and once it does, run this function right here. It also says watch for Mongoose to emit an event called err, and if it ever does, run this function right here. So in practice, these two event handlers right here are our method of figuring out, hey, is Mongoose done with doing whatever it's done or trying to do? If it is, great, run this function or run this function. So in every single case, when we try to initiate this connection, I will expect either this function right here to run, saying good to go, or this function right here to run, saying, hey, something just went not quite so nice. One thing that I just want to mention, just to be really clear, open and err right here, these are both very particular events that we're passing to Mongoose. I'm not making these words up. They are events that are a part of the Mongoose library. So at some point, we'll go check out the Mongoose documentation. If you go in the documentation, you'll see these events listed in there as stuff that you can listen to. The last thing I want to mention is a little bit of this fat arrow syntax right here. And just because I've had some misunderstandings in the past, when I say fat arrow, I'm like the words fat arrow. And that's modeled after like this symbol right here. This is supposed to look like a fat arrow pointing sideways, which is distinguished from a skinny arrow, which is with a dash greater than symbol. So this would be a skinny arrow. This is a fat arrow. So you'll hear me refer to these as fat arrow functions, which are another part of ES6. In practice, they behave nearly identically to normal functions with a function keyword. With Mongoose, there are a couple locations where you do not want to use fat arrow functions, okay? I will be very sure to point those out to you, okay? So there are a couple locations where we will not want to use fat arrows. I will be darn sure to make sure you know where they are. All right. I swear not all explanations of code will be as long as this took, but as we start up with this course, I'm gonna make sure that I throw just a ton of detail at you, hit all the fundamentals as early as possible. And then as time goes on, we're gonna kind of wean off of the in-depth discussions, and it's gonna be a lot more about writing a lot of fast code and just making stuff happen. So we'll pick up the pace over time. The last thing I wanna do is I wanna try running this file at the command line just, to see what happens. Well, let's just see what happens. So at the command line, here I am right here, I'm going to execute this file by running node test/test_helper.js. Let's run it, see what happens. Okay, well, I got a message that says good to go. So presumably our Mongoose library is successfully connecting to our MongoDB instance. If you did not get a success message right here, if you got an error of any kind, one thing that I want to remind you is that you need to make sure that your MongoDB database is running. So if you did not run that brew services start stuff, assuming that you're on assuming that you're on OS X, make sure that you run MongoD to get your service running. Mine, in this case, is already running, so I get an error message here. If you still get an error message after that, hey, feel free to drop me a private message or post on the forums, and we'll figure out what's going on here. Just out of curiosity, let's try changing out this local host right here and just see what happens with that error message. So I'm going to change it to just host, which I'm going to assume is going to throw an error message right here. So I'll stop my server by pressing Control-C. That kills the process. And I'm going to start up the test file again. And okay, well, that's definitely looks like an error message to me. So I think that it's pretty safe to say that at least this first little bit of code that we've placed is working correctly. I am going to change back the connection string up here to localhost, like so. And I'm just going to verify that everything still works. Okay, cool, we're good to go. All right, that's it. Discussion for the first part of our code. Again, it will not always be this long and this in depth, but for the first part, I want to make sure everything's crystal clear. Let's continue in the next section and continue working on our test environment. In the last section, we discussed all the code that we added inside of our test helper file. I think we spent a lot of time on it, so I'm not going to do any rehashing about what we discussed inside of here. Instead, I'm going to say that we're going to move forward and focus on using another part of Mongoose. So at this point, we've used Mongoose to connect to our database. Now we're going to use Mongoose to create a new collection of data inside of our database. You might be able to tell or guess from the name of this project that we're going to create a collection of users. So our database is going to store a big list of a bunch of different users. That's the goal of this application. We're then going to write some test files to make sure that we can properly create new records inside the database and read and write and update and all that kind of good stuff. So to add this new collection of users, we need to understand a little bit more about how Mongoose works. So let's check out a diagram really quick that's going to help us understand what's going on. Inside this diagram, on the left-hand side, I've indicated what is called a user model. We use Mongoose to create models that represent a record in a very specific collection. The user model right here represents all of the records that sit inside of a user collection. Now note that we have not created a collection of users in our database yet, but we will very shortly. So I'm going to talk as though our database already has a collection of users. All right, we're just going to assume that it's going to be in there. Even though this thing is named user model singular, we still think of it as representing the entire collection of users because it has a bunch of functions on this model right here that we're going to create with Mongoose for working with all of the records in our user collection. The user model will also be used to create objects that represent single instances or single records within our collection as well. So by these lines that go off to the right-hand side here, we are going to use this user model to create instances of the user model that represent a very single user or a single record in the database. So I might have a single record in my database that represents someone with the name of Joe, another one that represents Alex, and another one that represents Amanda. So just to be clear, we have the kind of user class or user model, and then we have user instances, which represent single records in our collection. The other important thing to remember or to know about user models are that they have a very important property to them called a schema. The schema tells us exactly what properties we expect each record in the collection to have and what type of data we expect it to be. So for my schema on my user model, I'm currently indicating that every user should have a name. And in theory, if we kind of sit down and think about, well, what type of data would a name be? Chances are it would be something like a string, right? I would want my name to be like a string of Joe or a string of Alex or Amanda. I wouldn't really want to have a name that is a number or an array or an object or anything like that. It really only makes sense to have a name of a string. So we'll need to focus on or keep in mind how to implement this schema thing as well. So I think at this point in time, let's create a new file in our project. We're going to create it inside of our source directory because this is going to have some actual implementation details for our project. And inside of this file, we'll create a new user model. So in my code editor, I'm going to flip over to my source directory, and inside there, I'll make a new file called user.js. So inside of here, we're going to define our user model, and then we'll make use of it inside of all the different test files that we will create over time. For right now, rather than make this section run too long, I want to do just two quick things at the top, and then we'll continue in the next section and finish up with our implementation of the user. So at the very top, I'm going to require in the Mongoose library. Whenever we work, I keep on misspelling it Moongoose. There we go, Mongoose, much better. Whenever we're working with any data inside of Mongo, it's almost a given that we're going to need to import the Mongoose library or require it at the top of our file. Next, I want to pull a very specific property off of the Mongoose object that we just required in. I'm going to put on const schema equals mongoose.schema. This schema object right here is what is going to allow us to create a schema for our user model. And remember, our schema is the thing that says, I expect my model to have a name property, and that name should be a string. So let's take a quick break, and then we'll continue in the next section and figure out how we use the schema object right here to create a new schema for our users. In the last section, we created a new file where we are going to create a model that represents a user. So that's going to be the core unit of data inside of this application. It's going to be a user. We'll create a user model in this file, and then we'll end up testing it inside of our test directory. Remember that a user model represents all of the data in a single collection in our Mongo database. So when we create this user model, Mongoose will automatically create a collection of users in our database as well. When we want to refer to a specific model out of our database, we will create an instance of the user model, and that will represent just a single user. So in the last section, we left off with the first two lines inside of this user file, where we first required in Mongoose, and then we pulled off a single property called schema. We're going to continue work inside this file now by creating a schema for our user. In practice, this ends up being not too bad in like the very simple cases where we just have like a name property, but over time as we come back and start to add more properties in, the schema is going to get a lot more confusing. So for right now, we'll kind of keep the discussion on the schema a little bit light, but over time when we come back and talk about the schema more and more, we'll get a lot more discussion around it. So I'm going to create a new schema for my user, and I'm going to assign it to the variable user schema. So I'll say const user schema equals new schema, and I'm going to pass an object into this that's going to configure the schema that we're about to create. So I'm going to say that I expect every user in my application to have a name property, and I expect it to be a string. String right here is a reference to the base string class, or object I should say, inside of JavaScript. So this is a special global variable that you have access to inside the language. All JavaScript implementations have access to string right here, so this is not something that is tied specifically to Mongo or Mongoose. Now that we've created the user schema with a name of type string, we can feed this into Mongoose to create a new user model. So taking a look at this diagram, just to make sure it's nice and clear, the user model represents the entire collection of data that's inside of our database. The schema is just a very small component of that model. The schema is only something in here that kind of tells the model, hey, here's the different properties I expect this thing to have. So the schema is only a small portion of what makes up an overall user model. So below this user schema that we just created, I'm now going to create my user model. I'll say const user with a capital U equals mongoose.model. We're going to name this thing with the string user, and then I'm going to pass in the user schema to let this thing know that we expect it to follow the schema right here, where it should have a name that is a string. So I'll pass in user schema as the second argument. Now this line right here, this is where the real magic starts to happen. This is where Mongoose starts to do a lot of work behind the scenes. When we create this new user model, a couple things happen. First off, Mongoose says, hey, Mongo, do you have a collection called user? No? Okay, I'm going to go ahead and make it. So this string right here is what controls what the collection is called inside of the Mongo side of things. Remember that Mongoose is really just a wrapper around the Mongo library or Mongo database, just to make our life a little bit easier. And so this is part of the simplification that Mongoose gives us. We don't actually have to go into Mongo and manually create a collection of users. Mongoose is going to take care of that for us automatically. The second argument in here instructs Mongoose about the schema that we expect this collection of users to follow. So by passing in the user schema right here, we're saying, hey Mongoose, anytime you're working with a user, we expect them to have a name, and that name should be a string. Finally, we return the result to user, or we assign the result to user. This capital U user variable right here is now what we will refer to as the user class along with user model. And we'll kind of use that term interchangeably, user class and user model. It does not represent any particular user inside our application. It represents the entire collection of data that's sitting inside of our database. Personally, I find that one of the hardest things to wrap my head around, at least when I was first starting out with Mongoose. Remembering that this thing is not representing a single user, it represents the entire collection of data. Now the last thing that I want to do inside this file is make sure that any other file inside of my application that requires this file in can get access to the user model that we just created. And I can do so by writing in module.exports equals user. Now, if anyone else inside of my node project tries to require in this user.js file using a similar syntax up here at the top, they will get a reference to the user model. It's extremely common inside of every model file that we'll create in a project to export only the model class out of here. So anyone else that wants to make reference to a user or create a user or find a user out of the database can do so with the user class, user model, whatever you want to call it right here. Okay, so this file is looking pretty good. What we've got in here forms the absolute core of just about every single model that we'll ever create with Mongoose. So every other file that we'll ever make will have a very similar structure to what we have right here. We'll certainly add in new parts of schema and a couple other methods on user, some odds and ends, but in general, we'll have import statements at the top create the schema, export, create the model, and then export the model at the bottom. Okay, this is looking pretty good. I think that we might even have enough code here to start writing some tests using Mocha. So let's continue in the next section and get started with that. In the last section, we created our first model file, which represents a user in our database. I'm purposefully keeping a little bit of the discussion about this model and why we created it just a little bit light, because trust me, we are going to talk so much about models later on in this course, you're going to get tired of it really quickly. So now we've created this model, I want to write some code inside of my test directory to test this thing and make sure that we can actually insert a record into our database, see that it exists, and then just make sure that everything's working as we might expect a database to behave. To write this test, we are going to have to learn a little bit more about how Mocha works. So as I said earlier, if you don't know anything about Mocha or testing, no problem, we're going to cover it all from scratch. But if you do know what's going on, don't worry, we're not going to draw out the discussion too long. So let's get started. I'm going to keep this a little bit more to the point by first creating a new file inside of my test directory. I'm going to make a new file, and I'm going to call this create test.js. So the purpose of this file right here is to write some test in here that is going to make sure that we can create a new user and save it to our database. That is the purpose of this file right here. Before we can actually write in some code that's going to test that that actually happens, we need to learn a little bit more about how Mocha expects us to structure our tests. This is a diagram of the type of structure that we're going to write for all of our tests when we start writing code with Mocha. At the very top level of every test file, we're going to have what we refer to as a describe block. Block is a little bit misleading term. It'd be better labeled as a describe function. So we are going to pass describe, or we're going to call a function called describe, and we're going to pass it a function. Inside of that function, we're going to have a variety of it blocks. IT, like just it. It block, just like describe, would be better referred to as an it function. So we will call a function called it, and inside of this function, we'll put in a little bit of syntax or a little bit of code to test a very specific part of the code that we have inside of our user model. Both the describe function and the it function are provided to us automatically by Mocha. So we don't actually need to require any code in or anything like that. We can just start using describe and it inside of our test file, and everything is going to work automatically for us. I've taught a lot of people a lot about testing in the past. I found that kind of dwelling on test structure ends up being a little bit confusing, and usually it ends up being smoothest to just kind of get our hands dirty and write a test or two. So at this point, I think we'll flip back over to our test file and get started off by writing our first test and seeing how it goes. So I'm going to flip back over to my test file. And inside of here, I'm going to write out my top level describe function. So I'm going to call the function describe. The describe function takes two arguments. The first is a string that describes the test that we're about to write, and then the second is a function. Let's first do the string, and then we'll decide what to do with the function in just a second. I'm going to say this test is going to describe creating records. And as a second argument, I'm going to pass in a fat arrow function, like so. The purpose of this string right here is just to modify the testing feedback that we get from Mocha. It has absolutely nothing to do with how our tests are written, ran, anything like that. It is solely for the purposes of us figuring out what tests are breaking when we look at our test report to figure out what's going on. In general, I recommend using some reasonable names for these strings, just something where you could glance at it and say, oh yeah, okay, that's a test where they're doing something about creating records. That totally makes sense. Inside of the function that we pass as the second argument, we will place a variety of it blocks. And remember, it is a function just like describe is. So let's put down an it block. The it function takes these same arguments as describe. So the first argument will be a string, and then the second is a function. So for the first argument, I'll say it saves a user. and then I will pass in a function as the second argument. Cool. The it block is the absolute key to all testing inside of Mocha. Whenever Mocha sees an it function like this right here, it's going to say, the user or the developer is trying to run some type of test inside of this function right here. It will queue up all of the different it functions inside the entire test suite that we've written, and then we'll run them all one at a time. Inside of every single it function that we make, we need to make what is called an assertion. An assertion is a piece of code where we say, I really hope that this value is equal to this value. The idea behind the assertion is to actually do the test, the actual part that says like, hey, is my code running appropriately? By default, Mocha does not include any tooling inside of here for automatically giving you the ability to make an assertion. And I say that because we automatically got access to describe an it, but the same is not true of making an assertion inside of the it function. Let's take a quick break and then come back in the next section and figure out how we make an assertion inside of our test file. In the last section, we created a new test file called create_test. Create_test is meant to test to make sure that our user model can correctly create a new record in the database. Just to clarify on the name of this file a little bit, all of our test files will end with _test. So when I say create test here, I don't mean like, hey, I want to create a test. I'm saying that we are testing the create functionality of our user model that we just created. We left off in the last section by saying that inside of an it statement, we need to make an actual assertion, something that is going to compare one value to the other, and then Mocha is going to interpret the result of that comparison and tell us either our test failed or it passed. The last thing that I had mentioned was that Mocha gives us global access to this describe and it function, but it doesn't give us global access to anything to actually make an assertion. So to make an assertion, we have to import an assertion library at the top of our file. Now this was already installed for us when we installed Mocha, so we don't have to do any work here. We're just going to say const assert equals require assert. We use this assert thing right here. It is a function to make an assertion within our it block. The assertion is going to expect to be passed a Boolean of some type. So traditionally we will compare two values and say I assert or I expect that like this value is equal to this value. If it's true, then our test pass. If it fails, then hey, our spec is going to fail. Let's just see how this thing works in practice. I'm going to say assert, and I'm going to assert that, how about 1 + 1 = 2? Nice basic comparison here. This statement right here is going to evaluate to true, so I would expect my test right now to pass. To run our tests after we put some assertion together, we use the command line to run our test suite. So I'm going to flip back over to iterm, or whatever terminal it is that you're running. It doesn't make a difference if you're using iterm or the built-in terminal. And once here, I'm going to run the command npm run test. Now when I run this, we're probably going to see an error message here. By default, we usually use the convention of npm run test to run our entire test suite inside of our project. But at this point, we haven't actually done any setup for the command npm run test just yet. So we need to first make sure that we put in a little bit of code somewhere inside of our project to make sure that our test suite actually gets executed. So the question very quickly becomes, where the heck do we run this command? Where do we write this thing, right? Well, that's part of the purpose of the package.json file that we created when we first started up this project. I'm going to open up the package.json file. And inside of here, you'll see that there is a scripts section inside of this file. One of the only existing script that we have right now is the test script. And when it's ran, it prints out error no test specified and exits the process with an error code. Okay, well, that's definitely where the error message that we just got came from. So we can see right here, error no test specified. Clearly it's coming from the script right here. So we are going to delete the message that's in here right now. I'm just going to take out the entire thing, everything from echo to exit 1. Then we're going to replace it with our testing command. So I'm going to place in here just one command, mocha. Do make sure that you have the term mocha inside of double quotes. You don't want to have it inside of single quotes, like that. You also don't want it to have just mocha by itself. You want to have mocha surrounded by double quotes like so. Now that we've defined our testing command, we can execute our test suite at the command line by, again, running npm run test. As just a little bit of side knowledge, if we ever add any other scripts inside of this file, we can run them by using the same type of command right here. So if I made another script called script, I don't know, print file or something, whatever we want to run, I would invoke it from the command line by running npm run print file. All right, anyways, let's run the test and see what we get. So we'd run npm run test, and we get the describe string at the very top where it says creating records. We still see the same string that we saw before of our Mongoose library connecting to Mongo. And then we see the individual it statement that we just added, saves a user, and it looks like it's passing because of course 1 + 1 is in fact 2. Just for posterity's sake, let's make this test fail. I'm going to say 1 + 1 = 3, which is, of course, I think it's not true. I don't know. Let's run this again. And then this time around, we get a nice big red error message that tells us, yeah, something went wrong here. You thought this thing was going to be true. In fact, it was false. This is part of why it's really great to have nice string statements that you pass to describe and it, because you can imagine that if you start getting like several hundred tests inside of a single project, you want to be able to find, or at least have a reasonable idea of what was tested when a test actually fails. So we know by looking at this description right here, creating records saves a user. All right, creating records saves the user. Okay, it's this test right here that's failing. Definitely makes it a lot easier when you have a nice string description. All right, I'm going to scroll back down to the bottom. And now we know how to create or how to execute tests and make assertions inside of our Mocha code. We're going to take another pause, and then we're going to come back and dive right into testing the user model that we created a couple sections ago that currently sits inside of our source directory. So I'll see you in just a second, and then we'll do our test for our user model. In the last section, we created our test file and successfully executed a couple of tests inside of it. We did so by using the assert function inside the it block. Assert right here is a very important function. It's not, I'm going to say that's a little bit of a piece of magic with Mocha. As soon as Mocha invokes an it statement, if it sees any it statement call the assert function, it will record the value that is returned from assert right here. So definitely very important piece of Mocha. In this section, we're going to continue by writing our first test around creating a user and saving it to the database. For this first test that we're going to write, we're going to take it nice and slow, and then over time, for all the different other tests that we're going to write inside this project, we're going to pick up the pace just a little bit. I'm going to start by first deleting the it statement that I have inside of here. Now, inside of this test file, I probably want to have access to all the code that is written inside of my user file or my user.js inside the source directory, right? Like the whole purpose of this test is to make sure that we can use this user model that we created to save something to our database. So it definitely makes sense that we want to have access to that code inside of this file. To do so, we will first import or require in the user model to this file. So at the very top, I'm going to add in another require statement. I'll say const user equals require, and now we need to pass in a string that's going to get us access to this user file right here. Now you might think to yourself, okay, no problem, let's put user. Unfortunately, that's not quite how require statements work. We need to pass a path to require here that walks us from the current directory that this test file is in to the directory that the user file is in. So to walk over, or to give a directory path that's going to get us over to source, we are currently inside the test directory. We need to go up one directory into users, So I'm going to say dot dot slash. Dot dot slash means go up one directory. We're then going to walk into source. So I'm going to put down source, and then I want to specifically require in the user file. So I'll say user, like so. Notice that I don't actually have to specify the .js file extension. I can just say user, and that's it. So now the user variable inside of my test file is equal to the user model that was created when we did our mongoose call right here. As a reminder, this user model that we have right here represents the entire collection of data that sits inside of our Mongo database. We specifically represent it with a capital U to indicate that this is like a special class of user, like a class object, as much as a class as JavaScript can make. So now that we've imported or required in our user model, we can use it to create a new user inside of our it statement. We will create the user, and then we will save it to the database, and then we will write some amount of code to say, hey, did this thing actually get successfully saved? So we're going to take these 3 steps one at a time. First, we save or we create a new user, then we save it, and then we somehow write some code to figure out whether or not the user was saved. All right, that's the game plan, the next 3 steps. The first step, creating a new user, is probably the easiest of the 3, so we're definitely lucking out here. We get to do the easy part first. This is definitely one of those places where I'm going to throw a little bit of code on the screen, and then we'll talk about exactly what's going on, okay? So I'm going to create a new variable called Joe. Joe is going to be our user. All right, he's going to be our guy. To create a new user called Joe, I'm going to say new user, and then I'm going to pass in an object with the properties or attributes that I expect Joe to have. Right now, our user model only has a single property assigned to it inside the schema, right? If we go back over to our user file and look at our schema, we're saying right now that a user can only have a name, and that name's got to be a string. So when I create a new user, I'm going to say that he has a name, and I'm going to pass in a string for his name, which in our case is going to be Joe. And that's all it takes to create a new user. We're going to see a lot of different variations on creating models over time. So this is the simplest form that we're going to see. In the future, we'll see a couple other fancy ways as well. One thing I want to be really clear about is that we use the user model, like the user class, to create a new instance of user. So capital U user right here, this represents all models. It's like the overall definition of what a user is. When we use it in combination with the new keyword and assign the result to Joe right here, Joe becomes an instance of a user. So he is, the Joe variable right here represents a very discrete record that we want to eventually save to our database. That last part is really important as well. By creating a new user like this right here, this operation does not automatically save anything to our database. So just making this, nothing saved to the database. We have to explicitly attempt to save Joe to our database in order for us to actually see him appear inside of our Mongo data. So let's take a quick break and we'll come back and figure out how we actually save Joe to our database. And once we figure that out, we'll use our graphical client, RoboMongo, to just verify that our data is successfully being saved into MongoDB. So let's take a quick break and we'll figure that part out. In the last section, we used our user model to create a new instance of a user, which we labeled Joe. One thing I want to make sure is crystal clear is that when we create a new model like this, Joe does not automatically get saved to our database, so he's not persisted. Right now, Joe is just sitting inside of memory inside of our program, and it's 100% up to us to make sure that we actually save him to get it saved to our database. We also, in the last section, outlined a 3-step process for writing in our test here to make sure that we know how to save a user to our database. First, we would create an instance of a user, which we just did. Second, we would save this instance to our database. And then number 3, we would write some code to make sure that our user was successfully saved to the database. All right, so that's our 3-step plan. Again, we've already done step 1 right here, so now it's time to move on to step 2. Inserting records into our database, I'm going to say it's both challenging and simple at the same time. It is simple because the basic syntax for saving a record is really easy to remember, but it is a little bit more complicated because there's a lot of considerations around saving a model that are going to come into play as we start to explore some of the advanced functionality of Mongoose. So right now, we're very lucky because we get to just do the very simple thing to save a model. To save an instance of a model, like if we want to save Joe to our database, if we want to persist him to the database, we will write joe.save, like so. So this line right here actually reveals a lot of information to us about how Mongoose works. Joe, like this object right here, whatever got returned from new user, is clearly not a plain JavaScript object, right? It clearly is not just consisting of like name : Joe. By calling save, it's really, what that means is calling new user right here must return an object with a bunch of functions, a bunch of functionality tied to it by default. So this instance of user right here, Joe, has a ton of functions attached to it that we can call at any given time, one of which is save, and we'll use many other functions over time as well. So once this line of code right here executes, I'm going to expect that Mongoose attempts to insert this record into our database. I think that what would be a really good test right now is to not really worry about running our Mocha tests or writing in an assertion or anything like that. I think that what would be really nice is if we just ran this file as is, and then we use RoboMongo to check out our database and make sure that this thing actually gets saved to it. All right, so let's go down that path. We're going to take a little bit of a diversion right now. So to run this file, we will run our test suite. And it's totally okay that we don't actually have any assertions in here or anything like that. We just want to make sure that this line of code is actually executed. So inside of my terminal, I'm going to run my test suite by running the command npm run test. Remember, this is the test command that we just set up. So I'll run this. And we get a creating records, saves user, everything's green for what it's worth. One thing that's really worth noting is that if you do not make an assertion inside of a it block, which we are currently not doing inside of here, right? We're not calling assert or anything like that. Mocha will just assume that all of your tests passed. So even though we don't actually have any tests or any assertions inside of here, it just thinks, yeah, sure, whatever, everything looks good, sounds great. All right, so in theory now, we have called joe.save, which means our record should be inside of Mongo. So I'm going to open up RoboMongo, which we installed a little bit ago. So here's RoboMongo. I'm going to open it up. And then I'm going to connect to our local database, our local instance of MongoDB. Once I click connect, I see my local instance pop up on the left-hand side. You'll notice that I have users test in here already. Users test, the database, was created the instant that we connected to that database inside of our test helper file using mongoose.connect. So if you recall inside of here, we said, hey Mongoose, when you connect to our local instance of Mongo, create a new database in there called users test. So the instant that we connected to Mongoose and saved a record, Mongo automatically created a new database called users test inside of there. So I'm going to open up this database, and I'm going to open up this folder called collections. And then inside of here, I'm going to find this users collection. All right, so this is it. This is our users collection. This is where all of the different users that we will create inside of our application will be saved. We'll end up having one user per line in here. Right now, it would appear so we have just a single user. If I expand this record, you'll notice that I have a name of Joe inside of here. And so clearly this is the user that we just attempted to save inside of our test file. You'll also notice that Joe, when it was created, was automatically assigned an ID property, specifically _ID, and it has a value of this long string. One thing that I want to point out, like really particular, because this is a total gotcha in Mongo, like total gotcha, it's something that will bite you in the rear. Whenever you want to refer to an ID of a record, you might be tempted to just say like oh yeah, just here's the string, the like raw ID. In fact, when data gets or an ID gets stored inside of Mongo, it gets wrapped with this helper called object ID, which is an object that helps Mongo just kind of keep track of its IDs. We'll talk a lot more later about what this object ID thing is right here and the impact that it has on some of the queries that we write whenever we use the core or like underlying Mongo drivers rather than using Mongoose. All right, anyways, that's getting a little bit off topic. I apologize for that. The real important thing here is that we ran our test file, we created Joe, and then we saved Joe to our database, and we automatically saw him appear to pop up inside of here, exactly what we wanted. So clearly Joe is getting persisted to our database. There's just one small little thing that I want to check out. I want to run my tests again. So at the command line, I'm going to again run npm run test. I'm going to run this thing. And okay, everything looks good again. And now I'm going to come back over to RoboMongo. And I'm going to refresh my table or my collection here by pressing Command R. On Windows, it's probably Control R. When I do that, you'll see that now I have two records inside of here. I have the original Joe that we created the first time, and then I got another Joe from when we just ran it again. Every single time that I run npm run test, it creates a new user inside of my user collection. So I want to ask you, do you think that in a testing environment, would this be a bad thing to have happen? I'm going to let you ponder that a little bit, and we'll continue the next section, and we'll decide whether or not this is a bad thing to have happen inside of a testing environment. So think about it for just a second, and then we'll make a decision in the next section. In the last section, we saw that every single time that we ran our test suite, we would add a new record to our collection of users. And I asked, do you think this would be an issue? Every single time we run our test suite, we get a new user in here, and it never apparently seems to go away. The answer is yes, definitely will be a problem. Here's why. Let's assume that maybe we write a test where we insert a record into our user's collection, and then maybe we do a search over that collection and say, hey, does like someone with the name of Joe exist inside of here? Well, if we never do any cleanup to this collection of users, that test will always succeed no matter what, even if our implementation is actually broken. So we need to make sure that we somehow do a little bit of cleanup every single time that we run any test inside of our test suite. So here's going to be the goal. I want to make sure that every single time that Mocha starts up, we empty out our collection of users, then we'll run a test, empty out the collection of users, run a test, and repeat again and again. This will make sure that every single test that we have runs in relative isolation and that no data from any other test starts to mess around with another test. You might be thinking, well, what about the performance side of things? Don't worry, on the performance side of things, clearing out all the data inside of a collection will have a near negligible impact on how long it takes to run our test suite. So let's add in a little bit of code that makes sure that every single time before we are about to run a test, we will drop all the records inside of a collection of users. To do this, a little bit more easy than you might think. Okay, it won't be that bad. I'm inside of our project directory, inside the test folder, and I have open the test helper file. Inside of here, I'm going to add what is called a hook. A hook is a function that will be executed before any test gets executed inside of our test suite. So let's define the hook, and we'll talk about exactly what it's doing. Underneath the Mongoose connect statements, I'm going to say before each, and I'm going to pass it a fat arrow function. Before each is a hook. It will run before each test in our test suite. And so that's where the name before each comes from. And so really it's meeting the exact same kind of criteria we set up here. So inside this before each, we'll empty out our database. Then our test will run. The before each will run again. Test will run. Before each will run again, and so on. I think you get the idea. So now the challenge is, inside of here, we need to somehow find our collection of users and just drop all of the records inside of there. Mongoose gives us another handy way of working with the MongoDB collection behind the scenes. So remember, Mongoose is all about giving us a nice handler onto MongoDB. This is a little bit of trivia. The code that we're about to do here, you could certainly look through the API and figure out how to do it. I'm going to give us a very direct solution. So I'm going to say mongoose.connection.collections.users. This is a direct reference to our collection of users sitting inside of our database. Now once here, we can call the drop function on our collection of users. This means, hey, take all the records that are inside of here, all the records that are inside the users collection, and just delete all of them. Just toss them all out the window. This definitely fulfills our requirement of making sure that we clean up all of our records in between, or after, or excuse me, before each test that we run. And there's just one more little detail to be aware of in here. One last little detail. As we've seen, whenever Mongoose starts to reach out to Mongo, it takes a little bit of time, right? We saw that with this connect statement up here. We had said, yeah, whenever Mongoose tries to reach out to Mongo, we have to wait some period of time, and then, hey, that connection is successful or it fails. The same exact idea applies to every single operation that we take on a collection as well. So whether we are reading from a collection, writing, updating, dropping all the records inside of it, it is an operation that takes some amount of time to execute. And so we need to make sure that since this takes some amount of time to run right here, we pause our entire testing environment and say, hey, wait, Mocha, like we're doing this long running thing right here. Don't actually run any more tests until this operation is complete. So let's figure out how we're going to tell Mocha to take a little bit of a pause while we are attempting to drop all of our users inside of the users collection. Let's figure that out in the next section. We've now got some amount of code that will make sure that our collection of users gets dropped before every single test that we run. The problem here is that making any type of operation on our database is asynchronous in nature. It takes some amount of time to complete. Mocha, on the other hand, doesn't have any default idea of asynchronous operations. It just says, hey, I'm going to run all my tests as fast as I possibly can. And so the result is, before every single test that we run, we can call before each. This drop operation will occur, but we don't really have any guarantee that the drop will be completed before our test actually runs. So we need to make sure that Mocha understands that it needs to do a little bit of a pause before it runs the next test. To do so, we'll take advantage of a feature in Mocha called the done callback. So here's the idea. Inside our before each, we're starting off a long-running process. Now, just to be clear, dropping our collection of users isn't something that's going to be tremendously long. I mean, we're talking about milliseconds here, but it's relatively long. It's going to take some amount of time that we don't really know. After our long-running process is complete, we will call this done callback. Done is a callback that is provided to us automatically by Mocha. After we call this done callback, our test will continue running. So clearly the magic here is this done thing. Let's add in a little bit of code to make use of done, and I think it's going to be a little bit more clear about exactly what's going on. So I'm going to flip back over to my code. Now it's kind of like two pieces of magic that are about to happen here very quickly. The first piece of magic is understanding that drop accepts a callback function that will be executed once it is done dropping our collection of users. So I'm going to pass this thing a callback function. This function right here will only be executed once all the users are done with our collection. And so this makes a fantastic point in time at which we can say, ready to run the next test. Like inside this function, this is the point in time at which we are ready to execute our next test. So that's piece of magic number one. Piece of magic number two is that done callback. Every single function that we write inside of Mocha that we hand off to a before each or an it or a describe gets called with a done callback. So as an argument to the function that we're passing to before each, I'm going to add in done. So this done right here is a little piece of magic. It tells Mocha, hey, when I call this function right here, when I just call it, that means I'm all complete with all the logic that I have inside this before each. You can now run the next test. So if we add in a call to done right here, that means, okay, after our collection of users has been dropped, like however many milliseconds that takes, we call done, and that is a signal to Mocha. That means you can go ahead and run the next test now. So now I'll save this file. And I think we're about ready to give this a test at our command line by running our tests again. So I'm going to flip over to my terminal. I'm going to run npm run test. We're still getting a success here, but now if I flip over to my collection of users, I can see that I've got just a single record inside of here. All my other records got automatically deleted. Now, just to be 100% clear, you might be thinking, well, Stephen, why is there even this one user in here? Well, the one user is in here because we only clear out our list of users before each test. So we clear out our list of users, then we run our test that attempts to insert or save a new user, and then that's it. Test suite complete, everything is done. So we only clear out our list of users before each test. So the real test here, to make sure that everything is really working correctly, is if we run our test suite again. So I'm going to run my test suite again. Here we go. It's going to run successfully. And now if I flip over to RoboMongo again and I refresh my collection, again, I've only got a single record in here, but I've got a new ID on this record. So again, we only clear out the test suite before each test. And that just means that after our test suite is complete, we might have like an errant record or two in here. Okay, so we're making strides on the test side of our setup here. However, our test itself still isn't making any type of assertion inside of here. Remember, that's what we use that assert function for. So clearly we need to add a little bit of code inside of this it statement to make sure that we actually create an assertion here to make sure that our record was actually saved. So let's get started on that process in the next section. We're now ready to make an actual assertion inside of our it block to make sure that Joe is successfully being saved. I want to mention really quick that I know that we're kind of focusing on a lot of Mocha topics so far, how the testing framework actually works. We've really covered the vast majority of all the Mocha stuff that we need to worry about already. So from here on out, we can just focus on Mongoose and MongoDB. And having this test environment means that we've got a very robust playground for kind of figuring out how these technologies work. So let's focus on making an assertion inside this it block. The first thing that I want you to remember is that we're calling joe.save right here. And as we've seen, that inserts a new record into our database. And when I say inserts a record into our database, I want you to immediately think, aha, we're working with Mongo. That means that this operation right here is something that's going to take some amount of time. It is asynchronous in nature, and it takes some amount of time for us to reach out to MongoDB and make a change. So that means that we need to have some method in here, some mechanism to say, okay, like wait for the save to finish, then make an assertion, and then go on to the next test. Okay. So to do so, we're going to be making use of promises with joe.save right here. Since it takes some amount of time to save Joe, a save call will return a promise. When the promise resolves, that means, okay, Joe is now inside of our database. So to get a notification or to get kind of a callback whenever Joe has successfully been saved, we are going to add on a .then statement like so. So now inside of here, we can basically ask the question, has Joe been saved successfully? That's really the question. That's what we have to figure out. So to figure out whether or not Joe has been successfully saved to our database, we're going to rely on a little nice part of Mongoose. Okay, let's figure out what that is. The part of Mongoose that we're going to be working with is a built-in property on every single model that we'll be working with. And so remember, Joe, I'm saying model, but I'm really talking about a model instance, which Joe is. Joe is a model instance. Whenever we have created a new model and it's just sitting inside of Mocha or kind of like our Node.js workspace or sitting in memory and it hasn't been saved yet, Mongoose will automatically place a flag on the model called isNew. If the record has not been saved to our database, isNew will be equal to true. And so as you can see in this diagram right here, the idea is, okay, Joe currently only exists inside of like Mocha land or Node.js land. Joe has not yet been saved to our Mongo database. Because Joe hasn't been saved to Mongo, isNew will be equal to true. On the flip side, once Joe has been successfully saved off to Mongo, once he is in the database and saved, this isNew flag will be flipped over to false. So inside our test suite, we can make use of this isNew flag to figure out whether or not Joe has been successfully saved to our database. Inside of our test, I'm going to add in an assertion, and the goal of this assertion is going to be to just look at that isNew flag. So we'll say assert joe.isNew. So if Joe has been saved to the database, isNew will be flipped to false, and we'll be asserting false right here. So clearly we don't want to assert false. We want to make sure that we always assert a truthy value. So I'm going to say Joe not is new. So once we have saved Joe, we want to make sure that he is not new anymore. He has been successfully saved to the database. Now the last thing we have to do is remember back just a moment ago, we were inside of our test helper file, and we said that this operation right here, clearing out our collection of users, takes some amount of time to execute. So we need to make sure that Mocha knows that we want to kind of like pause execution until everything is complete. And so that was where we brought in that done callback. We're going to use the same exact methodology in here with joe.save as well. So only after we have gotten our callback executed, this then statement, and we have made our assertion, will we say, okay, Mocha, everything's done, you can go on to the next test. So we will make reference to our done callback, and then inside of our .then, we will call done. One thing to remember is that done is available to every single it block and before each statement that we use in Mocha. We can optionally use it at any time, so we don't have to reference it, we don't have to call it, but once we do reference it in the arguments list, we have to make sure that we actually call it somewhere within our actual spec, our actual it block. All right, so let's give this a test. I'm going to save the file, and then I'm going to run our test command npm run test at the command line. And it looks like we've got a pass here. We do have a warning that we'll come back to in just a second. I do want to make sure that we test we check to make I want to make sure that we can make our spec fail as well, to make sure that we don't have an erroneous success right here. So I'm going to remove that exclamation mark. And so now we're going to be asserting something that hopefully is false, and hopefully we'll see our test fail. So I'll run npm run test again. And now this time, you'll see that we get a little bit of a pause in there. And if I scroll back up, timeout of 200 milliseconds exceeded. What this means right here is basically, hey, you got to your assert statement, the assert failed, and we never actually reached the done statement, and so we see our entire spec fail right here, which is exactly the behavior that we want. So back in the assert, I'm going to add back in the exclamation to fix the test back up. I'll run it one more time just to make sure everything's good, and okay, fantastic. So now we are getting a warning in here, something about deprecation warning, mongoose something something something. Let's take a look at this error and fix it up in the next section. In the last section, we successfully got our test running with an assertion. So right now, I feel like our test is definitely doing the right thing and testing the right behavior, but we were greeted with this nice big warning on here, something about a deprecation warning. It specifically says, Mongoose's default promise library is deprecated. Plug in your own promise library instead. So by default, when we use Mongoose, it has a default promise library plugged into it. As we've seen in the last section, whenever we do some operation with Mongoose that touches our database, it returns a promise. And that promise is fulfilled or rejected depending on whether or not the operation with the database was successful or failed. This built-in promise implementation, like the promise that gets returned from joe.save right here, is using this impromise thing that is plugged into Mongoose. Okay, so that's what that error message is saying. It is saying we have a default implementation of a promise library, but for whatever reason, we don't want you to use it. So instead, we have the option to plug in our own promise library. We can use a couple of very popular ones in the Node.js community, which are Bluebird, Q, or ES6 promises. In this course, we're going to be using ES6 promises because they're going to absolutely fulfill everything that we need for promises coming out of Mongoose. If all this stuff kind of seems like a little bit arbitrary, like, okay, why doesn't Mongoose just kind of figure this stuff out for us? Well, yeah, it kind of is. Mongoose does this to give us a lot more flexibility in what promise implementation we want to use, which for some users is really important. For some projects, that's something that you really care about. but definitely when you're first starting out, it's something that you don't really have to worry about too much. So all we have to do is fix up Mongoose's internal promise that it uses. Let's do that really quick. I'm going to again open up my test helper file. And at the very top of this file, after our require statement, I'm going to add in a new line in here. And we're going to say mongoose.promise equals global.promise. So on the left-hand side, we are saying, hey Mongoose, whenever you want to create a promise for like any type of interaction with the database whatsoever, we want you to use this library, this implementation of the promise library. Global.promise is a reference to the ES6 implementation of promises inside the Node.js environment. So we're basically saying with this line right here, hey, whenever you need to create a promise, just use the ES6 implementation. All right, let's save this line and execute our test again and see if we got that message to go away. So our tests run, and okay, everything looks good. You will notice that we still have that good to go message in here. I think that we probably don't need that message anymore, so I'm just going to take it out and replace it with a set of curly braces instead. So once we open up our connection to Mongo, okay, no need to do anything just yet. So let's run this again. And okay, everything looks good in here. Now there is one issue around open that we kind of started to address but never really wrapped up. So I'm going to go back a couple diagrams. If you recall looking at this one right here, where we had said, okay, Mocha is going to start up, we'll tell Mongoose to connect to Mongo, and then at some point in time, Mongoose will successfully connect to Mongo, and at that point in time, we should run our tests or show an error to the user. Well, we're definitely showing an error to the user, and we were able to test that out, but the one thing that we never really did was we never really, at that point in time, told Mocha to run our tests. All of our tests are clearly working right now, but this is more about handling the case in which, well, maybe for whatever reason it took longer than we expected to connect to Mongo, and maybe the test suite, Mocha, started to run our tests too soon. So to accommodate for that case, to make sure that we're always going to be in the clear 100% of the time and we're not just relying on Mongoose connecting to Mongo really quickly, we're going to wrap our connection statement with a before call. So we've already used before each before. This time around, we're going to use a slightly different hook. We're going to use one called before. This also will be called with a function that we write. The difference between before and before each is that before only is executed one time for all of your tests, your entire test suite. So for us, we only need to tell Mongoose to connect to Mongo exactly one time, right? Like we don't need to disconnect from Mongo between every single test. That would just add in some unnecessary pause. We only want to connect to Mongo one time, so we're going to use the before callback right here. So I'm going to take all of our connection logic, I'm going to move it up into the before call. All right, so that looks better. Now the last thing to keep in mind is that this connection to Mongoose is going to take some amount of time. So again, we want to say to Mocha, hey, just hold up for a second, pause execution, and wait until we have successfully connected to Mongo. So we are again going to reference our done callback, and then only once that we have successfully opened a connection to Mongo, we will call our done callback. So in other words, connect to Mongoose, wait however long it takes, and once that connection is open, inform Mocha that we're ready to go on to our first test. So let's now give this a little bit of a shot. I'll run npm run test again. And okay, looks much better. We're still connecting, all of our tests are still passing, but now we're guaranteed that in the case that maybe if Mongoose takes some long time to connect to, and who knows under what circumstances that might occur, we're going to not run any of our tests until our connection has been successfully made. Okay, so in this section, we both enhanced our Mongoose connection logic up here, and we also added in a default promise implementation for the Mongoose library. We're now at a pretty good spot where we have a single test written, and we've got a very solid setup for our Mocha test environment. So let's continue in the next section and start thinking about what other tests we might want to write around creating and saving records to our database. In the last section, we saw our first successful end-to-end test around creating a record. So we made a new instance of a user, which we named Joe. We saved Joe, and then we asserted that Joe was successfully saved to our database. Now that we know how to insert records to our database, we're going to work on how do we retrieve or query or find records out of our database. There's two distinct ways right now in which we might pull a record out of our database. First off, if we have a user saved to our database with the name of Joe and an ID of ASDF123 or whatever ID they might have, we could either try to find a user with a name of Joe, or we might find a user with a particular given ID. So these are both different kinds of read operations that we might take out of our database. The first one is kind of like a query of sorts, right? We might have many users with the name of Joe. And so we're saying find all of the possible users that we might have with the name of Joe. In the second case, we might find a particular user with this given ID where we would use this operation whenever we want to find a very particular user. So again, the first one's a little bit of a search type query. The second one is more like a lookup, like we're trying to find a very specific record. So let's add some tests to figure out how we might execute both these types of read operations with Mongoose and MongoDB. Inside of my project directory, I'm going to make a new file called reading test. We will come back and do a couple more tests with create, but for right now I want to kind of do the full spectrum of creating, reading, updating, and deleting records. So that's why we're going to skip on to reading for right now. The setup of this test file is going to look a lot like our create record as well, or a create test. So at the top we will require in the assert library and our user model, and then we'll put in a describe block to describe reading records out of our database. So first, let's start off with a little bit of boilerplate at the top. We'll say const assert, require assert, and user is require from source user. Remember the path here? We say go up one directory, go into the user folder, and then find the user file. So now we can specify our describe block. Let's say describe reading users out of the database. And then inside of here, we can place as many it blocks as we would want. I think the first query, the first type of search that we'll do will be around finding all the different users that we have in our database with the name of Joe. So we'll start off with saying it finds all users with a name of Joe. And then we'll pass in a function as our second argument. So now inside of here, our ultimate goal is to figure out how do we query our database, how do we execute a query where we find all the users with the name of Joe. But of course, at this point in time, when we're inside of this it block right here, we don't actually have any records in our users collection whatsoever, because we've already got that test helper file where we repeatedly drop our collection of users. So before we can actually find any users with the name of Joe, we actually have to make sure that we have a user with the name of Joe inside the collection in the first place. So to do so, we are going to add in another before each statement inside of this describe block. So we'll add in a before each in here. And the purpose of this before each is to insert a record into our users collection with the name of Joe, just so that we can have some amount of test inside of this file, all concerned with finding the record that we just inserted. Okay, that's our goal here. So inside of our before each, we'll make a new user of Joe. And by the way, I'm going to very purposefully not put on a describe or a const or a let in front of this Joe right here. You'll see why in just a second. So we'll make a new user with the name of Joe. And then we'll say joe.save. And because it takes some amount of time for this save to complete right here, we will wait for that to be successfully completed with a then statement. And then after the record has been successfully saved, we'll call a done callback. So again, we'll reference done as it's passed to the before each. So save Joe, and then go ahead and continue with all the rest of the tests that we want to run. Now again, you'll notice that inside of here, I didn't put in const Joe or var Joe, anything like that. The reason I didn't do that is that we might want to make reference to Joe, like this very specific model, down inside of our tests inside of here. So if I declare a variable inside of this before each, it is not magically available to somewhere else inside this file or any other function. And this has nothing to do with Mocha, nothing to do with Mongoose, anything like that. This is just pure JavaScript. If I declare a variable inside this function, its scope is limited to this function. It is not magically available over here as well. To make sure that I can actually make a reference to Joe inside of all the other it blocks inside of this file, I'm going to declare Joe ahead of time with a let statement. So by defining the variable Joe outside of here, we will then execute a before each statement. Joe will be assigned to something, and then when our it block runs, Joe will be a record or an instance of a user. Okay, so that's the whole idea here. We'll declare our variables ahead of time, modify them inside the before each, and then we can reference them inside of our it block. And again, this is not something having to do with Mocha in particular. This is just vanilla JavaScript and how the language works. Okay, so I think that all of our setup is ready to go. Now we just need to add in a query inside this file to reach into our users collection and find all of our users with the name of Joe. So let's take care of that in the next section. In the last section, we put together a little bit of test scaffolding for getting an exercise put together for reading users out of our database. To make sure that we actually had a user inside of our database to work with, we created a new user called Joe and then saved them to our users collection. So now we want to find a list of all of the users in our database with the name of Joe. That's our goal right now. In order to query our database in any fashion, we are going to make use of what's called a class method or a class function. Let's take a look at a diagram that's going to help us figure out how this works. There's two query methods that we're going to be making great use of with the Mongoose library. The first is find, and the second is find1. The most important thing to understand here is that these find and find1 functions are tied to our class of user in both cases. So because we created a user model, we got access to user.find and user.find1. If we had made another model called something like blog post, we would have blogpost.find and blogpost.find1. So each model class has its own find and find1 functions. The find and find1 functions both work by passing them an object with some criteria. This criteria right here is basically the properties that we want to search for. So in our case, because we want to find a user with the name of Joe, we might pass in an object with a key of name and a value of the string Joe. The criteria for find and find1 works identically. The big difference between them is what gets returned to us and how that return value works. We use find whenever we want to find all of the users that match this given criteria. So maybe I have many different users with the name of Joe and I want to find every single one of them. That would be a good use case for using the find method because that's going to find every user in my collection with the name of Joe. On the other hand is the find1 function. Find1 will search through our database or our collection with a given criteria, and as soon as it finds a record with a given criteria, it will automatically stop the query and return that single record just by itself. So the big difference between these, find finds a big collection or a big pile of records, whereas find1 is all about finding a very specific record. The last thing to be aware of is that find, since it returns a list of different users, returns an array, whereas find1 returns a singular record. So let's write a test, or kind of flesh out the test we've got written so far by using user.find and try to find all the users with the name of Joe. Now, of course, right now we've only got one user inside of here, but we'll write our test in such a way that, hey, we'll just assume that there's always going to be the singular user. So first, we will call user.findOne. Again, take special note here that we are referencing the user model, like the user class, not a specific user. All the query methods that we're going to find whenever we're working like looking at our existing collection is going to be using the user class as opposed to using or making reference to an instance of a user, like what we did when we wanted to insert a new one. So then we will call findOne with an object that will provide our search criteria. And sorry, I said findOne, really meant to say find, totally my mistake here. We're trying to find all users with the name of Joe, so we should be using find, not findOne. Totally my mistake. So we're going to pass this thing the criteria that we want to search with. So we're going to pass an object, and we want to say, find me every user who has a name of Joe. Now again, just like everything else that we've seen with Mongoose and everything that we will see coming in the future, this operation right here takes some amount of time to execute. So we don't just magically instantly get back a list of users. Instead, we have to chain on a .then and pass in a callback function. So the interior of this function right here will be called, with a list of all the users who were found. So I'm going to add in users, and this is going to be my list of users, however many were found. There might be 0, it might be empty array, there might be 10 users inside of here. For our test, we're really going to expect there to just be a single user, our user Joe. So if we're going any farther, let's just console log this thing. Let's just console log it and see what we have to work with. Also, don't forget that because this is an asynchronous test, and it is asynchronous because it's going to take some amount of time to complete, we have to make sure that we include our done callback. So I'm going to reference done for the it block, and then inside of here, we'll call done to tell Mocha, hey, this test is going to take a bit of time. Once we call done, you can go on to the next test. So let's run this. Let's say npm run test. And inside of here, we get a console log. It looks like, yep, it's an array. And we've got an object that represents our user coming out of the database. So let's take a quick break and then come back and figure out how we will write an assertion to say that, yep, our user was found successfully. So I'll see you in just a second. In the last section, we added our find query, and we were able to confirm with the console log that this found a list of all of our users in our database with the name of Joe. So here's a name of Joe right here. So now the question becomes, how are we going to write an assertion around this? How are we going to make sure that that first user in here is the Joe that we created up here? You might think, well, maybe we could just assert that they both have a name of Joe. Well, that would definitely work, but kind of the goal here is to make sure that we are finding this very particular user that we just inserted to our database. This would be a great use case of using the ID property that every Mongo record gets assigned. So if we flip back over to our terminal, you'll see that it has the _ID property. One thing to be really clear about with Mongoose and MongoDB is that even when we first create a user, like when we said new user right here and we assigned it to Joe, it was automatically assigned an ID by Mongoose. This works in kind of contrast to a lot of other ORMs and ODMs where an ID will not be assigned to it until it's actually saved to the database. So even though Joe right here has not yet been saved, it still has an _ID property. And that _ID is exactly equal to the ID that it will be saved with once it's actually inserted into the database. So Mongoose is really making a big assumption here. Mongoose is assuming that it can generate a unique enough ID before it actually gets saved to the database. So let's use that ID to write our assertion inside of our then block down here. So we are going to want to make sure that the first user in this user's array has an identical ID to Joe's ID. So let's give this a shot. So I'm going to write in an assert statement, and we'll say users at 0, so the first user in that array, Let's look at their ID property, and I expect that to be absolutely equal to Joe's ID. All right, so let's save this and let's run our specs. Let's see what happens. So let's say npm run test. And well, this definitely doesn't look good at all. Looks like our test actually failed. So reading users out of the database, test failed, the one we just wrote. And says specifically here, assertion error, false, true. So for some reason, it looks like our comparison here failed. Well, let's go ahead and console log out both these IDs and just take a look at them. Make sure that it's actually, what I just claimed about the Joe getting an ID created when we first create the record right here. Let's make sure that's actually the case. So I'll console log out the first user's ID, and I'll console log out Joe's ID as well. So I'll save, rerun my tests. And okay, there's the console log. Let me scroll back up to it. And if I compare both these IDs, well, that's interesting. They definitely look identical to me. So what's going on here? Well, this is definitely one of the biggest gotchas of everything around Mongoose and Mongo. If you recall, a while ago, when we were looking inside of RoboMongo, so I still have my users collection open here, I'm going to expand the singular record. And when we looked at the underscore ID property, we had seen that it had a value of not just the string of the ID, but specifically object ID and the string right here. So when we look at the underscore ID property of a Mongo or Mongoose record, we are not looking at a raw string of the ID, even though that's what it looks like when we console log it up here, even though that's what it looks like. In fact, what we are looking at is an object of object ID, which somehow encapsulates that string. It somehow wraps that string inside of it. And so even though these two records right here have identical IDs, the object ID that wraps them will fail an equals comparison test, like we have right here. So the big takeaway here is that the underscore ID property is a little bit misleading. It doesn't quite behave the way you would expect when it comes to comparison. To get a reference to the actual string ID, to like the raw string of the ID, we have to call underscore ID dot toString on both sides. So on both the users at 0 and Joe, I'll reference underscore ID and then call toString. This takes the object ID object and it pulls out the actual string that's sitting inside of there. And so we can compare the two strings, which I would definitely expect to be equal. So I'm going to clear out the console log statements. Let's save that. And then let's run our tests again. So let's say npm run test. And okay, definitely behaves much better now. So again, this is something that will definitely bite you in the rear once you start trying to compare IDs of any type. Because the underscore ID is actually an object ID and not a just raw string, as you might expect with many other databases out there and ORMs out there, we have to call the toString function whenever we want to make some kind of comparison between this ID and another one. Okay, so definitely wraps up a little bit of a gotcha here with Mongo. One other thing that I want to mention before we move on to our next test, where we will try out the find one function, is that it's definitely getting a little bit tedious to have to keep typing npm run test again and again and again and again every single time we want to run our tests. So maybe we should also spend a little bit of time in the next section to see if we can't come up with a little bit of a command to automate our test running. So let's take care of both our find one query, our find one test, and see if we can't enhance our test suite a little bit more in the next section. Our test suite is definitely coming along, and we're now getting a handle on not only inserting records with Mongoose, but also finding records once they've been saved. And so we saw a very simple query here where we attempted to find all of the users with the name of Joe inside of our users collection. The one issue I have with our test suite right now, however, is that every time that we want to run our tests, we have to write out the command npm run test. And so it definitely works, but that definitely gets a little bit tiresome at the same time. So in this section, we're going to make use of a little tool to automate running our tests for us. I'm going to flip over to my code editor and open up my package.json file. So if you recall, inside of here we had that scripts section where we added in the test command. So anytime that we run npm run test, we're actually executing the command mocha, which runs all of our tests for us. To make sure that our tests will automatically run for us anytime that we change any file in our project, which would really make our lives a little bit simpler rather than having to rerun this command every time manually, we're going to make use of a tool called NodeMon. NodeMon will watch our project directory for us, and anytime that any file in there changes, it will automatically rerun our tests. Now you might be curious, if you have a previous background with Mocha, you might be saying, well, Stephen, why aren't we going to use like -- watch, which has kind of the same effect. When we add on the -- watch right here, it will watch our test directory for any change, and whenever there's a change, it'll rerun our tests. The reason we're not going to use that is that the -- watch sometimes has a little bit of iffy functionality or compatibility with Mongoose. So instead, we're going to be making use of NodeMon, which just completely restarts Mocha every single time, as opposed to having kind of this running Mocha process at all times. Okay, so let's use NodeMon. We're going to use NodeMon in here by replacing our Mocha script. So I'm going to say NodeMon, and then whenever NodeMon sees a change to any file in our project, I want to run my Mocha command. So I'm going to say --exec, and I'm going to pass in a set of single quotes right here, and then in between them, I'm going to say Mocha, capital R, and min. Okay, so let's first just review what we just wrote, just because I want to make sure you got the syntax exactly perfect. On the outside, we have a set of double quotes. We have NodeMon --exec, and then an opening and closing set of single quotes. Make sure that these are single quotes on here. So anytime that any file in our project changes, NodeMon is going to run this command right here, Mocha -r and min. So we haven't seen the -r or min previously. These things are, these two options right here are all about the formatting of our test output. So -r and min are both going to condense down our test output, and it's also going to clear out any output from the previous time that the tests ran, so that it's really clear that, okay, like, hey, our test just re-executed, and we know that we're always going to have up-to-date output on our terminal. Once we run this actual script, you'll see what the -r and min do almost instantly. So let's just go ahead and run the thing. I'm going to flip over to my terminal, and I'm going to run npm run test. So when this starts up, you can see the effects of the -r and min instantly. They clear out all the existing input inside of here, and min will condense down all of the test language. So rather than seeing the description of every test that got ran, we just see 2 tests passing. And so this is just the absolute bare minimum to make sure that our tests are behaving the way we expect. So let's test the live reload functionality just a little bit. I'm going to open up my reading test file, and I'm just going to make a small arbitrary change in here. So I'm just going to take out this semicolon right here. I'll delete it, save the file, and then I can see NodeMon automatically rerun my tests. If I end up, say, making a test break, let's add on like a not in here, just arbitrarily, then we get, okay, nice big error message, test definitely failed. So it's definitely clear when our tests are failing. And if I fix the test back up, I'm back to passing. Okay, so this has been the NodeMon tool in action right here. Again, we're using NodeMon as opposed to Mocha's built-in watcher, because Mocha's built-in watcher has a little bit of compatibility issues with Mongoose sometimes. So now that we've got a much better way of running all of our tests, let's continue in the next section and continue with some more exploration of the user.findOne function. So I'll see you in just a second. In the last section, we enhanced our test suite by adding a NodeMon command to automatically rerun our tests whenever anything changes. And so functionally, it's just going to make sure that it's a lot easier to see some very live output from our test suite. If you have 2 monitors, a great practice is to put this terminal window on the second window, and then you can just, or second monitor, excuse me, and then anytime you change any code in here, you can just glance over at the second monitor and make sure all the tests are running. Of course, for me recording, we only got the 1 monitor, so I'm just going to keep everything on 1 window or 1 monitor and just alt tab between the 2. Anyways, time to get back to our actual tests. we now have made use of Mongoose to find a very particular, or I should say not a very particular, but any user inside of our users collection with a name of Joe. So now I want to go back and make use of the find one method to find a very particular user inside of our collection. Now, because in theory we might have many different users with the name of Joe, I want to try to find a user with specifically the ID of Joe, the one that we already saved up here. And so this use case of finding a user with a particular ID would be whenever we know the ID of a record, but we don't actually know any other criteria about it. And so this actually ends up happening rather frequently in a web environment, and it's something that we'll see later on inside this course. So since I'm writing a new test, I'm going to add in a second it block. And the purpose of this test will be to find a user with a particular ID. And I'll add in my callback again. Again, because we've seen this many times now, I am trying to find we're trying to make an operation that's going to touch Mongoose. So we will use the done callback in here because it's going to be an asynchronous test. So now inside of the test suite, or inside of the it block, we'll add on a call to user.findOne. As a reminder, whenever we kind of want to work with the entire collection, we use the model class of user. Whenever we want to work with a very particular record, that's when we start to use new user and then manipulate the user instance that gets returned. So I want to find a user with a very particular ID. In many other frameworks or ORMs, they have a lot of helper methods where you can sometimes just pass in, say like find something and just pass in the ID of the record you want to find. Unfortunately, Mongoose doesn't have the same functionality. It really expects you to always be passing in an object that's going to serve as the criteria that you want to use for your search. So we're going to pass in an object, and we're going to say, I want to find the first record with an underscore ID of Joe._ID. Notice that in this case, we don't have to use the toString because we're not doing any type of comparison or anything like that. Internally, Mongoose knows exactly how to work with that object ID thing. So Joe._ID right here is an object ID object, but Mongoose knows how to deal with that. So we can just say, here's the entire object ID, go find a record with an ID that looks like this. So this will tell Mongoose to go off and find the first user with this very particular ID. And then as we are very well getting used to, we can add on a .then case, which will be called with the very particular and single user that gets retrieved. So remember the big difference between find and find one. Find one returns a single record, find returns an array of records. So now we need an assert statement inside of here. So what might be a good assert inside of here? We could look at the ID and just compare the ID. Maybe another good assert statement would be to look at the name of the returned user and make sure that it's Joe. So I'm going to say assert user.name == Joe. And then we'll call done to wrap up the test. So I'll save this. Let's see how we're doing. And we got 3 passing tests. Just to make sure that everything's working the way we expect, I'm going to change that to mark, which is definitely going to fail. And yep, we see a nice big error message. Let's go back to Joe. Much better. Okay, so in this section, we saw the difference between find and find one. We also saw how we look up records with a very particular ID. So we're starting to kind of develop the range of tools that we have with Mongoose so far. We can insert records, we can find very particular records. Let's get into our next section where we're going to start to figure out how we modify existing records inside of our users collection. We've now written a handful of tests around creating users and reading users out of our database. I want to skip updating users who are already saved and go on to delete first. So we're going to figure out how we're going to delete users out of our database, and then we'll circle back around to updating users. And there's a very particular reason I want to show you a little bit more about delete first. Let's first set up our test file for deleting a user, and then we'll talk about exactly why we're going over to delete. So inside of my test folder, I'm going to make a new file called delete test.js. So inside of here, we're going to create a user and then figure out a bunch of different ways to get them out of our database. So let's first start off by putting down a little bit of test boilerplate. So we'll say const assert, we'll require assert, we'll get our user model or the user class from source user, and then we'll describe deleting a user. All right, so inside of here, or I should say the reason that we're skipping update and we're going directly over to delete is that this is going to be our first taste of some of the real truth behind the use of Mongo and Mongoose. And when I say truth, I'm referring to the fact that there are many ways to achieve the exact same effect in Mongo and Mongoose. And so deleting a user is going to be a fantastic example of that. So there are many different ways to delete records in Mongo, each of which have some, certainly some relevant application. Some of them are going to feel like, why are there so many ways to do this? But we're going to walk through each one and maybe we can get a better sense of when we might use each case. So let's check out a diagram. It's going to help us understand all the different ways to delete a record in our Mongo database. The first thing to understand is that internally, Mongoose does not use the terminology delete. It uses the terminology remove. So for purposes of our exercises, we're going to term this like deleting because we're thinking about create, read, update, destroy. But for all of Mongoose's terminology, we're going to be using remove. So inside this diagram, we've got a reference to the model class and our model instance. So when I say model class, I'm talking about like that user variable, like the capital U user. A model instance is an instance of the user class. So this would be like Joe. So Joe has a method attached to it called remove. When we call remove, that will delete Joe from our database. Our model class also has a function called remove. This remove over here, we will pass it some criteria. Mongoose will look at all the different users in our database, find any users that match this given criteria, and then delete them. Similarly, there's also find one remove and find by ID and remove. So in total right here, you can see there's really ultimately 4 different ways in which we might remove a record from our database. Remove attached to a model instance is most useful whenever we have like a direct reference to a record, particular record inside of our program. So if we've like already fetched Joe and we have like an instance of Joe, great time to use remove. If we want to delete all of the different records in our collection with some very generic criteria, like maybe find all of my users who have a name of Joe, maybe I've got 10 different ones, that's when I might start to use remove. Find one remove is a lot like remove over here, and find by ID and remove is also kind of related to model instance remove as well. Anyways, you can see that there's just 4 different ways and they're all, to some degree, pretty darn similar. So let's write some tests around each of these and see if we can't figure out how each one really works. So I'm going to flip back over to our test file. And we'll start off by adding a before each hook. And inside this before each, we will create a new user of Joe and save him to our database. So that inside of each it block that we create, we will remove Joe in some various fashion and then write some tests to figure out, or just to make sure that he was actually deleted. So first we'll declare a variable called Joe, and we'll write in our before each. I expect it to be an asynchronous before each, so I'm going to add in my done callback. Then we'll make a new user of Joe, so he's going to have a name of Joe. And then we'll say joe.save. And after Joe has been saved successfully, we'll call done, like so. Cool. So now we can add in a couple of the different it blocks that we want to have in here. First, we want to test our model instance remove. I'm going to be just very explicit with each of the it statements in here, just to make sure that it's very clear what each of these methods are coming from. Our class method remove. We'll do our third one of find and remove. Class method find and remove. And then finally, class method find by ID and remove. All right, so 4 different ways. Let's immediately get started inside this section with the model instance remove. So remember, whenever I say model in here, model instance specifically versus a class, I'm talking about using this Joe object to remove Joe from the collection, as opposed to using the user class, like capital U user class, to remove a record. So these 3 tests down here, we'll use the capital U user, and this model instance right here, we'll use the actual Joe instance itself to remove him. Okay, so model instance, definitely the easiest by far. So this would be the use case where we have already fetched this user, like we fetched him outside of our database, maybe we took some action with him, and then we eventually came to the conclusion that, you know what, Joe's done, we're tossing him. We don't need Joe anymore. So to take an instance of a model and remove it from our database, we just call Joe, dot remove. Now, just like every other way in which we touch our MongoDB database, this is an operation that takes some amount of time, and so it's going to return a promise that will be resolved when the operation is complete. So we, of course, are going to need our done callback, so I'll add that in. And so now we need to really think about, well, how are we going to test whether or not Joe was removed? I think that after Joe is removed from our database, we need to then search through our collection and see if we can find any existing user with the name of Joe. Then if we can find a user with the name of Joe, that means that remove must have not worked. Otherwise, if there is no user with Joe, then hey, test must be passing. But that definitely leads us into a little bit of a tricky case here with dealing with promises. Because we basically want to say, let this promise run, or let this kind of request run, let it modify the database, wait for that to be successful. Then once that's successful, go and execute this other query to find a user. And then once that is done, come back and actually make our assertion. So to make that happen, we can use a little bit of magic with promises. So we know that if we add on a .then, this .then will only be executed once the remove operation is complete. If we create a new database operation in here and return it from this .then, we can then chain on a subsequent .then, which will only be called once this second kind of little query inside of here finishes. So what I'm kind of getting at is if we add in user.find1, and we look for a user with the name of Joe, and return it from this first .then, this second one will not be called until find1 right here is complete. And then the argument to this .then right here will be whatever gets returned from this operation. So in other words, long story short, I would expect this second .then to be called with a user that was found by user.find1. So this is a little bit nasty right here. Let's first write the assertion. So I'm going to say I'm going to assert that user is null. In other words, we did not find a user. That's what I want to make sure have happen. And we'll say, add in our callback here. So let's kind of see if this works. And then I want to take a quick pause and come back and make sure that it's really clear how this kind of chained on promise is working here. So let's check out our test suite, 7 passing. Yep, I'm going to assume that's good. Let's update our, I'm going to say I expect this thing to be an empty object just to make sure this thing is actually failing or working correctly. Yep. So I'm going to say that it looks like it's working correctly. I'm going to change it back, make sure it works. Okay, so let's take a quick pause and then come back and make sure that we are really clear on how this promise setup is working right here. In the last section, we used the model instance function remove to remove Joe from our database or collection of users. We then saw a little bit of fancy footwork with our promises in here. The reason that we had to use a little bit of fancy promises was we had to make sure that the operation to remove Joe occurred. Then we had to go back through the collection again and attempt to find any user with the name of Joe. And so we essentially had 2 promises in a row that had to be executed sequentially. So that's really the key. We had to make sure that they were executed sequentially. To do so, we used a little bit of fancy syntax here. Most notably, from the first promise, we returned another operation that returns a promise. The second .then here operated on the promise that was returned from the find one operation. So with words, that's kind of hard to really understand. Let's try to look at a diagram and figure out what's going on. So we called Joe.remove. When we did that, it returned a promise. Inside that first promise, we said, when Joe is gone, try to find a user with the name of Joe. And then once that operation completed, this second .then right here tapped into the promise that was returned by this operation. So we then asserted that the query did not find a user. If we think about this in a slightly different fashion, you could think of Joe.remove as returning promise number 1. So Joe.remove returned a promise number 1 that we then chained onto. Then because that then returned a promise of its own, we now got promise number 2, which is what the second .then chained itself onto. So when this second .then was resolved, it was called with whatever the result of user.findOne was, which was supposedly a user, but since we know that there's not supposed to be a user there, we made an assertion to say that it was null. And then we called our callback of done to say, hey, Mocha, we're all done with our stuff. So yes, definitely a little bit of confusing little bit of work with promises here, but definitely a common pattern that we'll use frequently whenever we want to chain promises together. Note that we could have taken this entire .then statement right here and chained it directly onto user.findOne. Maybe we should do that really quick just to make sure it's really clear the alternative syntax we could have used. So I'm going to make a little bit of a quick change here. So if I do like so, this would have been equivalent code. So this reads a little bit easier on the logic side, but definitely the syntax is a little bit nastier. So this would have been remove Joe, then do our user.findOne and specifically chain onto that user.findOne with a .then. So it would have been equivalent, but a little bit nastier to look at. So I'm going to do a little bit of undo and go back to the code that I had before. Okay, so here we are back to where I was. So again, this is our first way of removing a record out of a collection. Let's move on to our next method, which is to use the class method remove. The difference between the instance remove and class method remove is that instead of referring to an instance of a user, like when we are looking at Joe, we are looking at the class of user overall. We specifically use class method remove whenever we want to remove a bunch of records at the same time. So remove a bunch of records with some given criteria. So in practice, we might call remove, and then we'll say, I want to remove every user with a name of Joe, like so. And that's pretty much it as far as the actual remove command goes. So now we can take all the same follow-up code to make our actual assertion. So I'm just going to copy paste it all down. So I'm going to take everything from the .then going down, and I'll paste it in like so. And I'll save. Let's check out our specs. And looks like I forgot to grab my .then callback. So I'm going to make sure that my class method remove right here, I'm going to add on the .then like so. So I'll add on the .then, and okay, now my test is passing again. So again, using the class method remove is a lot more useful whenever we want to remove a bunch of different records that have some common criteria. This is in direct juxtaposition with the model instance remove, where we're saying remove on this one very specific method or this one very specific record right here. So in this case, it wouldn't have mattered if I passed in some criteria, because this is not a reference to the entire collection of users. It's a reference to specifically just Joe. Okay, so another little method of removing a user. Let's continue with the last two ways of removing users in the next section. We're now ready to move on to our two final remove methods, the class-based method findOneAndRemove and the class-based method findById and remove. So both these are going to be somewhat similar in nature. They're both intended to find a very particular record and remove it. The big difference is that find by ID and remove works by looking up an ID of a record, whereas find one remove works by giving some criteria, and then the first record in a collection that matches that criteria will be removed. So this is where, again, things start to get a little bit repetitive in the Mongoose and Mongo world. Because if you think about it, we could really re-implement find by ID and remove by using find one and remove. We could just look for a record's particular ID and remove that one. So again, definitely some repetitive stuff, but getting a good handle on all the different options for modifying and removing records is definitely something to work towards. So let's add in a little bit of implementation for both of these. We're going to call the respective method to remove a record, and then we're going to have the identical follow-up where we're going to try to find the record that was just removed and then assert that it does not exist. So first we'll start by adding in the find one and remove. So this again is a class method, so we'll refer to the user model, then find one and remove. And then we need to pass in some very specific criteria for the name, or kind of something that represents a very particular user. So again, we'll look for a user with a name of Joe. Just to be clear about what I was saying just a moment ago about how we could re-implement the find by ID and remove. We could just as well do, ID joe.id like so. And that would be completely identical or equivalent to find by ID and remove. But we want to make sure that we can just find a record by looking up their name. Okay, so now again, we can copy paste down all the same assertion logic. So I'm going to grab both of the thens and the assertion inside. So I'll put that right in here. Do make sure that you don't have a semicolon after the find one and remove. That's an easy little typo to make. All right, let's save this and see how we're doing. So I'll save. And it looks like, okay, well, I keep making the same error. Did not reference the callback done inside of our new it block. So I'm going to make sure that I have done inside of here right after the it statement. And we can run again. And okay, definitely looking better. So 7 passing. I'm going to again just change out the assertion to make sure that this is a legitimate pass. This is always a really good test to do to make sure that you don't have some little typo that's erroneously causing some success. All right, and so it definitely fails, which means our spec is definitely passing. So we'll go back to asserting that user is null. In other words, the user is not found. Okay, so there's find one and remove. Absolutely fantastic whenever you want to find like a specific record by using some unique property. So in our case, we haven't really enforced any type of uniqueness around name. We haven't really put anything where we said, yeah, there can only be one person named Joe. But if we had, say, a good example would be like email. If we had very specific email addresses or very unique email addresses, and we wanted to find a user with a very particular email address and remove them, that would be a great use case for find one and remove. All right, so I think we're on a little bit of a roll, so we might as well just go ahead and finish up with find by ID and remove. I think you've probably got a pretty good idea of how this one's going to work. It is, again, a class-based method, so we'll reference user and then call find by ID and remove. And then rather than passing in an object here, we can just pass in the ID of the record that we want to get rid of. Now again, that same question as before with that whole object ID business comes into play. We don't have to worry about object IDs with find by ID and remove. Like Mongoose will take care of all that stuff for us. So all we have to do is pass in Joe ID, like so. Notice that we don't have to provide an object here of like a key of ID and a value of ID. It is just the raw ID by itself. And then after this, we'll put in the exact same follow-up logic again, like so. We'll save. And let's make sure, okay, I just keep on making the same error. I forgot to add in the reference to done. So there's my done. Okay, much better. And again, I'm going to make my spec fail just to make sure that everything is working as I would expect. Yep, looks like the spec fails when I replace what we are asserting with a falsy statement. And so I'll flip it back to null and just finally confirm, yep, everything's passing. All right, so there we go. These are our 4 different methods of removing a user. Again, this is really opening the door to something that we're going to find a lot of inside of Mongo and Mongoose. There are just more than one way to accomplish a given operation. So we're going to find a lot of the same operations or the same kind of methodologies for removing records or removing a single record, removing a bunch of records, all that kind of good stuff is going to apply to updating records as well. So let's continue in the next section and take a look at all the different ways we have available to us to update records inside of a collection. We're all done with the different ways of removing records out of a Mongo collection, which means we get to go on to our final method, which is updating records that have already been saved. So this is where the vast majority of complication with Mongoose is going to come in. So I'm just going to throw it out there right now. This is where we're going to start to learn a lot of what's going on with Mongoose and MongoDB. We're going to start off with the same functionality or same methodology as how we tackled deleting a user. So we're going to first look at the different ways of updating a user, and then we're going to start walking through all the different implementations. So the model instance methods for updating a record are pretty reasonable, all right? Like they're pretty digestible. But as soon as we start getting into the class-based methods, that's where stuff starts to get a little bit more interesting. So we're going to start off with the easy stuff, and then we'll move on to the little bit more complicated, in-depth stuff. Okay, so updates with model instances versus a model class. We have 5 different ways instead of 4 that we saw with removing. So clearly, definitely a lot of different ways to do the same kind of thing inside of Mongo. Without a doubt, I definitely feel like you're hopefully getting that impression right now already. With a model instance, we can either call update and pass in the update that we want to apply to a record, or we can do what I call the set and save method. So these are 2 separate functions, set and save, that we'll use to update a record as well. So let's first walk through these 2 model instance methods of updating a record, and then we'll figure out exactly what is so complicated about these updating. Okay, so let's get started. I'm going to start off by creating a new test file inside of my test directory. So I'll make a new file, and I'm going to call this one update test.js. And then inside of here, we're going to have a lot of the same exact boilerplate as before. We'll import or require some stuff at the top. We'll put down our describe block and then define our before each. So I'll start off with my assert. We'll then pull in our user model. So we'll require source user. Then we'll describe updating records, and we'll pass a function into that. We'll again need to declare a user ahead of time, who we're going to call Joe, and then create him and save him inside of a before each function. So at the start of every single test, we'll have a nice brand new fresh user to work with. So we'll say let Joe, and then inside of a before each, and we'll make sure that because we are going to save a record or touch Mongo in some fashion, we're going to receive the done callback inside of here. Then we'll make our new user with the name of Joe, and then we'll save Joe. So joe.save. And then after Joe is successfully saved, we'll call our done callback. Okay, so there's our boilerplate. Let's get started immediately on our first method, which will be calling a model instance update function. So we'll give this just a very clear and direct name inside of all of the it blocks that we're going to write. I'll say it instance set and save. So by that I mean an instance model type we're going to call set and save. Maybe we can do a better description than this. Maybe we'll say exactly what I just said. So instance type using set and save. Yeah, that's reasonable. Okay, so let's take a quick break, and then we'll come back and figure out how to use this set and save methodology for updating a record. In the last section, we started looking at all the different ways in which we can update records that have been saved to our database. So in total, 5 different ways using Mongoose alone. Definitely a lot of different ways of achieving an update. We start off by creating our update test file. And inside of here, we declared the first it block, which would be done by using the set and save methodology. So as we've seen with a couple console logs already, when we console log out a model, we can see in plain text all the different properties that exist on that model. Case in point, let's add in a console log right now inside of this it block to log out Joe. Let's just see what different properties Joe has. So I'll save the file, scroll all the way down, and okay, so it looks like he's got this __ v, whatever that might be. He's got a name property and the ID property. And we know that this ID, although it appears to kind of be like a string or something, we know that it's actually an object ID. So what's really important in here is we know that it has the property Joe. Inside of Mongoose, if we ever want to update a property that is existing on a record, we can use an instance method called set. So I'm going to call joe.set, and then I'm going to specify the property that I want to update. So I want to update the name property, and we'll say just totally arbitrarily that I want to update it to be Alex. So now let's console log Joe again. So I'll add in my console log. And now we can see that at first, Joe has a name of Joe, and then he gets an updated name of Alex. So set is used whenever we want to change one of the properties on an object or on a model instance. Just setting a property, however, does not reflect that to the database. So when we call set, no update is done. This is solely something that is done in memory for our model. I'm going to clear up the console logs here really quick. Okay, it looks good. If we actually want to persist these changes to our database, we will call the save method, the save one that we've been using throughout all the different tests. So we call save, and that will persist our record to the database. Save can be used after we have called set on some property. Okay, so like if we ever want to, as a single property, do like a couple updates over time and then eventually save it, perfect use case for this set and save methodology. So I set the name to Alex, and then I can call joe.save, and then put in our expectations to make sure that this was actually reflected into our database. So previously, we were testing out the delete methodology. I'm going to flip over to the delete file real quick here. So here's delete. And with all these remove methodologies, we had said, okay, we'll remove it, and then we will attempt to find that record in our database, and then we're going to expect it to be null. With the update methodology, for actually writing the test, I think that maybe we need a little bit different approach. I think maybe we need to make sure that we are not only testing that there is not a record called Joe, we should also be testing that there is a record with the name of Alex. So we're going to do a little bit of a different expectation or assertion inside of here. Instead, I think that we will pull up the entire list of users that we have in our collection at this point. So we'll just find all the users we have, and then we will assert that there's only one user in there, because there only should be one Joe for every single test. And then we will also assert that that single user has a name of Alex. So I think that'll be our plan for assertions in here. We're going to need to collect the entire list of all the users in our collection, which means we will need to use the find method, which we've already seen when we were doing our read test before. So as we were using it before, we would call user.find on the model class, and then we passed in an object with all the different properties that we wanted to kind of filter by for the find. So inside of here, inside my then, we'll call user.find. And then the question becomes, well, what criteria do we want to pass in? If we want to fetch a list of all of the users in our collection, we can pass in an empty object. So if we pass in an empty object, that means I have no criteria for this find operation. Just give me everything that's in there. And so if all of our code is working properly, I would expect user.find with an empty object to return a single user with the name of Alex. Okay, so that's kind of my expectation, my belief of what should be happening here. Because we are returning another query right here, or another operation to the database, I can chain on another .then, which will be called with the list of all the different users that were found by that query, or that user.find. So inside of here, we can write all the different assertions that we might want to make. And sorry, I call this user, it should be users plural, just to be 100% accurate. A find operation will always return an array, and so I would really want this to be users to indicate, hey, there might be multiple in here. So I think that to make some reasonable assertions here on this list of users, first off, I really only expect there to be one user. Second off, I expect that user's name to be Alex. So we'll say assert users.length is 1. And then we'll assert that users at 0, so the very first user in there, will have a name of Alex. And then finally, we'll toss in our callback. And this time, I'm not going to forget to reference my done inside of the it block as well. So there's my done. All right, let's give this a test. I'm going to save it and let's see what we get. All right, so 8 tests passing. Looks good. So the whole idea behind set and save is that we might want to update several different properties in different steps, and then only after making all those updates will we make the final save. This methodology right here for updating a record in this kind of piecemeal fashion is best when we want to update a couple of different properties, but we might want to do so in different steps. So in the context of like a web server kind of world, maybe we've got some incoming request and it wants to like set off a whole variety of different updates. And maybe the logic for figuring out how we want to update this thing might be a little bit complicated. So we might make a function that would be something like, function maybe update name, and that would take in our user model. And then maybe we'd have a function of maybe update email. And that would take in the user model as well. And then after calling both these things, so maybe we would call maybe update name with our user, and then maybe update email with user. We could then just go ahead and say, hey, you know what, whatever just happened, take those 2 changes that were made and save that to our database. So with this type of approach right here, we could have 2 different functions that maybe updated the email or name property. We don't know, maybe they did, maybe they didn't. But just to be 100% safe, after both possible updates, we could then call save. So the benefit of this approach is we would have 2 separate functions with all the logic for just deciding whether or not we needed to update this one singular property. And then only after everything was done would we call save. This would be a lot better and preferable to maybe making the change inside of here and then calling save inside of this function as well. Because we could end up with calling save once in here and once in here as well, which would definitely be not ideal because we would be touching our database twice. Okay, so just a little bit of an example of where we might want to use this set and save methodology. So this is all pseudocode down here, so I'm just going to be sure to take that all out. And I think that we're good to go. So that's it for set and save. Let's continue in the next section and walk through the methodology of updating a model instance with the update function. We've now got our set and save test put together. The next function that we'll be looking at is a model instance's update function. So we want to update a very specific property on a model instance. So let's see how that would work. I'm inside of my update test file where we've already got our first test for the set and save. And so beneath this test, I'm going to add in another it block for testing a model instance can update. Okay, so we'll add some code in here to update the name of a single user. So again, because we are working on a model instance here, we are working with like a reference to Joe specifically. So this would be another example where we take an instance of a model as opposed to the user class. So like the capital U user. Updating or using the update method on a user instance, totally not unlike a lot of the other kind of patterns we've seen before. So we'll look at Joe and we want to update a single property on here. In particular, I'm going to say that I want to update his name to be Alex. So with update, we pass in an object that lists the new properties that we want to apply to it. So just take Joe, toss a new name on, that's pretty much it. That's all we're doing here. As we are very much tired of me hearing, I'm sure, this is another operation that's going to touch our database. Of course, it means we have to add in our done callback and then go through the entire same process of pulling out a list of all of our different users and then making some assertions about them. Now, when we were going through our delete tests, I kept on console, so I'm going to flip over the delete file real quick. This is our delete file. I kept on copy pasting, these 2 then statements into every single test. And so each of our tests definitely had a lot of repeat or duplicate logic inside of here. And looking at update, well, we're definitely going down the same path here as well, where we've got this like, dot then, the second dot then, and then some assertions inside of here. Rather than doing a whole bunch of copy pasting all over the place, I'm going to suggest that maybe we make a helper function that will make this assertion for us. And all we should have to do is call this assertion function that we'll write in just a second with our query or our update. And then the assertion function should basically just kind of like take it from there. Okay, so let's see what this might look like. I'm going to scroll up a little bit, and above the first it block, so right between the before each and the it block, I'm going to define a new function, which I'm going to call assert name. So I'm going to assume that this is going to be called with the result of a save or update or something operation. So basically it will be called with an operation that results in a record being updated inside of our user's collection. I'm going to call this thing, for lack of a better term, operation. We're just going to call it operation. So then we'll take that operation object. So in this case, I would be doing something like calling assert name with joe.save, like this right here. The operation will be a promise, so we can chain onto it these dot thens and the assertions, and that'll pretty much wait for the operation to finish saving or whatever operation it's doing. It'll find a list of all the users and then make some assertions. So in practice, like taking all these words and condensing them down to actually something actionable, basically what we want to do is take both these dot thens, I'm going to cut them, I'm going to paste them after the operation, and then I'm going to update my it block to call assert name, and I'll pass in joe.save. So the code that I have inside this it statement and assert name completely, well, I should say nearly identical to what we just had. Call joe.save, this will return a promise, we hand that promise off to assert name, and then we'll take the promise, which we are receiving as something called operation, and chain on our two dot thens. Now there's just one last thing that we have to keep in mind here. We have to make sure that we pass through our done callback function. So the second dot then we'll call done. We need to make sure that we take this callback function and we pass it into assert name so that when we try to call done, it basically, make sure it's in the same scope and knows what we're talking about. So I'm going to pass the done as a second argument to assert name, like so. And then inside of assert name, we will receive it as a second argument, done, like so. All right, let's check out our test output and see if this is working. Okay, well, I still have 9 tests passing. I'm going to go ahead and I'm going to change the name expected right here to, how about just Bob, just to make sure that the test is still working as we expect. So I'll save this. And okay, fantastic. Definitely getting an error there, exactly what I want to have happen. So I'm going to flip this back to Alex, and looks good, much better. Okay, so now for all the rest of the tests that we write inside this file, rather than chaining on a bunch of dot thens and all that repetitive stuff, we can just call assert name, pass in the promise that comes from the update operation, and then pass in done as the second argument. Now looking back at the update with using a model instance that we just added a little bit ago, we still don't have any type of assertion in here, so we can again make use of assert name, pass in this update operation, and done, which we will receive here in just a second. Not going to forget. Let's start with that just to be 100% clear. So here's our done callback. And we can call assert name. We'll pass in the update operation as the first argument. And then the second argument can be done. Let's do that. We'll run it. Hey, 9 tests passing. Fantastic. All right, so this is definitely looking good. We've now seen 2 of the different ways in which we can update a model instance. Okay, so this is when we have a very particular record already loaded up. So like we've already reached into our database, we've pulled out Joe, and now we want to make some update and save him. Whereas using the set and save methodology was really nice for when we wanted to make some incremental updates, this bulk update functionality where we can just pass in an object and one go, just do the whole thing, just save it immediately, is really nice whenever we know that, okay, like we want to just update a couple records, and save it instantly. So behind the scenes, functionally, set and save, set and save and update, essentially identical. The big difference is how you, or the different situations in which you would make use of them. Set is when you want to do some piecemeal updates over time. Update is when you want to just do one go, save it all, call it done, we're all set. Okay, so that's our two model instances. We're now going to start moving into our class-based updates. So class-based update, find one and update, and find by ID and update. So again, these are where things are going to get a little bit more interesting. Let's continue in the next section and see exactly why they're going to be a little bit of fun. We've now got our two model instance methods for updating a record down pat. So we covered update and we covered the set and save methodology. We're now going to move on to our class-based updates. In practice, all three of these updates are going to work very similar to how the remove helpers worked as well. So we can call update, that will update all of the records, just like remove would remove all the records that match some criteria. Same thing with find one and update, and same thing with find by ID and update as well. I had mentioned in the last section that as we're getting into these model update or these class-based update functions, that things were going to start to get a little bit more challenging. We're first going to walk through the simple way of using these three helpers right here, and then we will talk about how they can be kind of enhanced and used in a much more advanced fashion as well. Okay, so first we'll cover the easy functionality, and then we'll update it to be the much more interesting and complex stuff. So let's get started with walking through update, find one update, and find by ID and update. Now we just saw all three of these kind of like in the remove context just a moment ago. So we're going to get through all three pretty quickly and just kind of knock them all out in one go. We'll start off by putting in our it statements. So we'll say about a model class can update. We'll put in our done callback and our function. And then we'll just do all three of the it statements in one go. So a model class can update one record. So this will be find one and update. And then finally, a model class can find an ID, or excuse me, a record with a ID and update. Okay, and then I'll zoom out just a little bit so you can see that entire line. So just a very long string description and then done and close off the function. I'm going to zoom back in just to make sure everything's nice and legible. Okay, so let's get through this one at a time. So for the model class can update, the function signature is very similar to the delete that we were working on just a moment ago. So I'm going to flip over to my delete test file. Inside of our delete test file, we called user.remove, and then we passed in a kind of selector of sorts. The selector right here said, find all of the different records that match this criteria and then just remove them. So update works in much the same fashion. We'll call user.update, and then we'll pass in an object to select all the records with this given criteria that we're going to add on here. So we're going to say find all of the records inside of this user collection with the name of Joe. Now, what really distinguishes update from remove is that we actually have to specify, well, what is the update? What are we trying to change here? So as a second argument, we pass in the updated attributes that we want to be applied to all of the found records inside of the user collection. So I'm going to pass in a second argument of an object, and I'm going to say for every record in this collection that has a name of Joe, I want to replace it with the name of Alex. And that's it. So this will find all the records with the name of Joe, replace it with Alex. So now we can pass this this kind of operation right here off to our assert name query. We'll say assert name. And because this is a pretty long line, I'm going to just open my parentheses up here, and I'm going to indent this next line. I'll do a comma, and then I'll close it off like so. And then as the second argument, I'm going to pass in my done callback. So do make sure that you remember the done callback up here as well. So we're calling assert name, pass in the operation, comma, pass in the done callback, and then close off the assert name. All right, let's check out our test output. And okay, well that definitely looks bad. I probably saved at a, yep, definitely saved at a bad time. I'm going to start up my test script again. And how are we doing? All right, well, it looks like we've got still a nice big error inside of here. And, totally my fault. So in the two it statements that we added, I'm referencing the done callback, but we're not actually doing anything with it. The instant you reference this done callback, Mocha expects to see it called at some point, and so right now we're not calling it, and so both tests are failing. Let's just continue with the two other it statements, and then we'll just come back at the end and make sure all of our tests are passing. All right, so on to a model class can update one record. So again, this works just like we saw with remove. We are finding a very particular record. The instant we find that record, we'll update it, and then the entire operation stops. So this is really useful when you want to say update a single record by passing in a unique attribute. So in the case of users, maybe we've got a unique email for each user. So maybe we want to find a user with a very particular email address and then update one of their attributes. So we'll say user, find one, and update. I want to find a user with the name of Joe. And when we find that user, I want to update their name to be Alex instead. All right. So that's the entire operation right there. We'll find the first user with the name of Joe, set their name to Alex. That's pretty much it. Let's wrap this thing with another assert name. Place our comma at the end of the line over here. Place our done statement, and then close off the assert name. Okay, so I know that I just did a little bit of key work in there, but we're following the same exact pattern as in the test above it, where we call assert name, we pass in the operation, we got a comma, and then the done. All right, just one more, and then we will make sure that all of our tests are passing. So I bet you can guess how this find one and update, or excuse me, find by ID and update is going to work. It's going to look very much like the update that we saw a little bit, or excuse me, like the remove that we saw just a moment ago. So find by ID and remove, it's going to work just the same way with find by ID and update. So we'll say user find by ID and update. And then we need to pass in the ID of the record that we're trying to find. So for us, it'll be joe.id. And then the update we want to do is to update their name to be Alex. And that's it. So we'll call assert name again. Pass in the operation as the first argument, done as the second, and then close off the function call. A good use case for find by ID update, just near exactly the same as with the delete case or the remove case over here. You know, we might have just an ID to a very particular user, which is definitely common in the web world. You know, it's very common when working with servers to just pass around IDs or just a reference to a record inside of our database. So maybe as we pass around an ID at some point in time, we decide, you know what, we need to update their name to something else. And if that's the case, we can go ahead and do so all in one operation with this find by ID and update helper. All right, so now it's time to go and check our tests out. And scroll down to the bottom. Let's start our test suite back up. And fantastic, looks like all of our tests are passing. Okay, so it looks like everything is good to go in the update world. So in this section, we covered the 3 easier methodologies of implementing a model class's update, find one update, and find by ID and update. So in the next section, we're going to start starting to move away from the shore a little bit. We're kind of still a little bit close to the shore. We're going to go into the deep end a little bit more and figure out some of the more complex methods of implementing updates on a collection of records. So let's take a quick break and then start going into the deep end. We've now walked through our 4 different basic operations in a MongoDB database. We have created records, read, updated, and destroyed, all 4 basic operations. We just finished up in particular with using the class-based update functions. We're going to move forward now onto some of the more complex examples or complex uses of these update functions. And so this is where we're going to start to learn a lot more about performance inside of MongoDB. First, to kind of frame this or kind of give you an idea of where we're trying to go, I want to add in a new property to our user model. Okay, so right now we currently only have a single prop in there called the name. That's all we have right now. I want to add in another property called the post count property. This post count property is going to be kind of help us pretend that we're making a blog post app of some sort. So maybe we have many users and each user has some number of blog posts. We'll store the number of blog posts that a user has as a simple integer on each user. So Joe might have 5 blog posts, Alex might have 1, Amanda might have 12. So everybody has probably a different post count. I want to first start by adding this post count property onto our schema for our user model. Remember, whenever we add a new property to a model, we have to update that model's schema. Our model schema sits inside of our project directory inside of the source folder. So I'm going to open up the user.js file, and inside of here we can find our current schema. I'm going to update the name, or excuse me, I'm not going to update name. Right after the name, I'm going to put on a post count, and this is going to be of type number. And I'll save this. And now really quick, I'm going to flip over to my terminal. You'll notice that in my terminal, all of my tests are still passing over here. So just because I add in a new property on my schema does not mean that any of my existing tests are going to start to fail. I can have as many properties on my schema here as I would like. Mongo just says, hey, this kind of really just tells Mongoose that this property might exist and what type it should be. So it's really just kind of helping us out. It is not really enforcing any requirements for the data that our model actually has. Not until we start adding some validations to our model and saying okay, I expect the user's post count to be a number greater than 0 or something like that. Would I expect to see some tests start to fail? Okay, so now we've got our post count here. Now I want to, again, remember we're trying to frame this whole discussion around these advanced updates that we might make using class-based updates. So I'm going to throw in a situation here. I'm going to say I want to write a new test inside of our update test file. So I'm going to flip over to update test. I'm going to scroll down to the bottom, and I'm going to say that I want to add a new test inside of here where we will try to just take a user and increment their post count. That's literally all I want to do. I just want to increment their post count by 1. So I'm going to write a test that says a user can have their post count incremented by 1. And then we'll add in our function after it, like so. Okay. Now you might be thinking, well, Stephen, hey, that's not hard, right? We've seen that set and save method where we can do something like joe.set post count, and maybe we'll set it to 1 or something like that, and then we can save it, and that's pretty much the whole ballgame, right? Well, again, specifically, I want to look at the class-based updates. So the class-based updates over here. So I want to be able to say for this wide range of users, like maybe every user who has a name of Joe, or every user, period. I want every user, or this whole big group of users, to get 1 added to their post count. So rather than having an instance to a function, I want to use the class-based function to update a whole range of different users in one big go. Okay, so I'm going to take this out. Before we start writing any code, I want to flip back up to the top of this file, to our before each, where we define Joe at the top. And I'm going to give him a starting post count of 0. And I'm going to do this right here just to make sure that when we actually need to go and make an assertion inside of our test, we'll know that if we are incrementing our post count by 1, then our final post count should be equal to 1. Because we're starting at 0, we're going to increment by 1. 0 plus 1 is 1, which I'm sure you very well know. Okay, so basically at some point in time, we want to write a test in here that says something like assert that Joe has a post count of 1, right? 'Cause that's kind of like where we're headed. That's what we're trying to accomplish. So I want you to think, using all the tools that we have right now that we've learned about making updates, how might we update every user, or maybe just like every user with the name of Joe, of which there could be very many, add 1 to each of their post count. So again, you might be thinking just like that set and save, that we could do something like user.update name of Joe and I want to now set their post count to 1. Well, this is a little bit of a trap right here. This will kind of lead you down the wrong path. This update right here that we're specifying, this is saying set every user's post count to 1. This is not incrementing by 1. It is setting their post count to 1. So if we had a whole bunch of users who had like a post count of 20 or 30 or 112, it would reset each of their post counts back down to 1. I could even make this test not behave exactly as we would expect by changing the starting post count up here to like about 20, right? Well, now when we do that update down at the bottom that I just added, we would be subtracting 19 instead of just adding 1. So the built-in update functionality doesn't quite work the way we would expect here for making a very small adjustment to a model. So clearly this functionality right here isn't going to work either. Okay, so clearly there must be some good solution, all right? There's got to be some solution to this. I just want to make sure it's really clear why we might go or not go down that particular path. So the next thing you might think would be, all right, Stephen, like, we get it. You want to update a whole bunch of different users. What if we do a find for every user who meets some criteria, like has a name of Joe, and then we'll iterate through each user. We'll look at their current post count, we'll increment it by 1, and then we'll save it. So this would be kind of a diagram of how that might work. We might say, hey, for every user inside of our collection, fetch it, load it up into our server, or for us, like our test suite, update the post count by 1, and then save the record back down to the database. Now this would definitely be a methodology that works, but there's one big problem with this. This means that for however many users we're trying to update, we're going to take all those users and we're going to load them up to our server. Any time that we can avoid loading data into our server from Mongo is a big win from us from a performance standpoint. So even though this approach right here would work, even though we could fetch all these users, increment some value, and then save it back to the database, we avoid this approach as much as possible because we always want to avoid actually saving any or actually loading any data to our server as much as possible. So instead, we're going to take a slightly different approach. All right, so this is finally after laying out all these bad scenarios that you might try, this is the one that's actually going to work. So what we're going to do is we are going to use our server, or for us like our test suite, to send an instruction to our Mongo database that is going to say, find these users, so like every user with the name of Joe, and update their post count by 1. Specifically, don't set their post count to 1, but increment their post count by 1. So unlike the example we were just looking at, where we could have been loading a bunch of users, making a modification, and then sending them back to Mongo, we are going to entirely rely upon Mongo to make these changes for us. So this whole discussion that we're having is opening the way to what we call Mongo update modifiers. And it's definitely one of the more challenging ideas or topics inside of Mongo. I'm going to pull up a little bit of documentation really quick inside my browser window. So here's Chrome, and I'm going to do a search for Mongo update, not operator, or yes, Mongo update operators. That's totally fine. So Mongo update operators, I'm going to click on the first link right here. This is a collection of what we call Mongo update modifiers. We can use these modifiers or operators in conjunction with the update function inside all of our different methods of updating a record. So this works not only with the update function on a class, we can also use it with find one and update, and also find by ID and update as well. It works with all of them. What these do is they allow us to send an instruction off to Mongo, and Mongo will execute that instruction for us inside the database. The reason that we use these operators is that they are fantastically efficient and performant compared to grabbing an entire record, loading up to our server, changing it in some fashion, and then sending it on back. So we can take a quick glance at some of the different modifiers or operators we have access to. First off, inc increments the value of the field by the specified amount. So this sounds an awful lot like the post count that we're trying to do. We can multiply the value of a field, we can rename a field, We can set the value of a field. This is another very useful one. We can unset a value. By the way, set right here, just to be really clear, this means like change the value of this field from whatever it is right now to this new value. We can specify an operator that will say only try to make an update if it's less than this existing value or greater than this value. And then we can also specify the current date in here as well. In practice, each of these operators are fantastically useful whenever you want to change a lot of different records in one go. So if you're ever updating just a single record, you don't really need to reach for these. But if you want to update like 5, 10, 15, 20 records all at once, you are going to want to start to reach for these update operators. Okay, so long discussion about update operators. Let's continue in the next section and figure out how we actually use them. In the last section, we started talking about update operators. Specifically, the one that we want to use is the inc or increment modifier. The purpose of this modifier is to send an instruction off to our database, and Mongo will be 100% responsible for updating a big set of records for us. So again, anytime you want to update a bunch of records, you are going to want to start to look for your update operators. So let's fill in our test and make use of this update operator. I'm inside of my update test file, and I'm in the test specifically for incrementing a post count by 1. So inside of here, we're going to end up using the update function much like we saw earlier. So here's a model class can update. We said find all the models or all the records with the name of Joe, set their name to Alex. So we're going to use a very similar syntax this time around. Inside of the it statement, I will add an assert, or excuse me, we're not going to do an assert name this time around. We're going to have to write our own little assertion ourselves. We'll say user.update, and then we want to find every user with the name of Joe. And we specifically want to set an update operator. So I'm going to add in another object here. We're going to specify the update increment operator with $inc, and then we'll say I want to find the post count property on every object that is found by this criteria right here, and I want to update it by 1 or increment it by 1. So this is it. This is how we use these update operators. We specify the type of operator that we want to use, then we point it at an object with the key of the property that we increment or we want to increment, and then the amount that we want to increment it by. You will notice that the documentation that we were just looking at, there is no dec operator or like decrement operator. And if you kind of think about it for a little bit, okay, yeah, that kind of makes sense. There's no decrement operator because we can increment by a negative value and achieve the same effect. So if you ever want to decrement a bunch of records in one go, you can still use increment, but just pass in a negative value here. Okay, so I think that this will go ahead and do the update for us. Now we have to think about what type of test we're going to write in here. So like that, at the start or just a moment ago, I made a mistake and I was about to say, well, yeah, we'll use assert name again. This time around, we're not going to use assert name because we are incrementing a post count value, and we're probably going to want to write an assertion around looking at the value of the post count as opposed to looking at the name, which is what, of course, assert name does. So instead, I think that we'll go through the similar practice as we've done twice now. I'm going to chain on a .then. Inside of here, we'll add in a query to pull our Joe model, or a user with the name of Joe, out of our collection, and then we'll make an assertion about Joe's current post count. So inside of here, I'll add in a query to find one user with the name of Joe. So notice that we have not changed Joe's name in any way, shape, or form. We've just incremented the post count property. So after we find the user with the name of Joe, we can take that user and we will assert that user.postCount is equal to 1 now. Note that we could not just look at Joe inside of here. When we use the find one, find one right here has no idea, no clue that we have a variable or a model instance inside of this test file called Joe. Okay, so just to be 100% clear, just because we are fetching this record out of our database, it's not going to magically update Joe for us. So I could not do assert Joe.postCount right here because Joe is not getting updated. Joe is our server side or JavaScript side representation, which is not getting magically updated. Okay, and then after that, after we assert the post count, we'll make sure that we close off with our callback of done. And again, I'm not going to forget to add done to our it function as well. So there's my done. Okay, so let's save this and see how we're doing. So flip over my test. Yep, looks great. Everything's green. Let's try playing around with it a little bit. So I could increment by 10 instead. And okay, now I get a failure. Let's update the assertion and say, okay, well now post count should be 10. And fantastic. So now I've got 13 passing, which means that we are successfully incrementing the post count by 10. Okay, so this is our first test of operator or modify operators or update operators in Mongo. Again, increment is definitely one of the best uses for this. Certainly also set is very useful as well. The operators are best used whenever you want to avoid or you want to have some amount of logic being sent off to Mongo, right? You want to kind of tell Mongo, hey, you need to kind of do some operation on these records. It's usually the case that we don't quite get as much leverage out of the set operator, even though I kind of mentioned it in particular. Because if we're just setting a value of a field in a document, then we might as well use the update operator, or excuse me, just the update function as we saw earlier. So set just updates the value of a field, which is 100% equivalent to what we're doing right here, where we're setting a name of Alex, right? We're like saying just without any logic or any introspection of the current value, just update Alex, or just update the name to Alex. So it usually ends up being the case that increment and multiply as well are a little bit more useful as far as these operators go, but there are some times where you might want to actually check a couple of these other ones as well. Okay, so that's our update modifiers. We'll certainly see them again later on. Let's take a quick break and then move on to our next topic in the next section. We've now conquered our 4 most common ways of manipulating data inside of our Mongo database: create, read, update, and destroy. So now that we've covered these basics, we can start to explore a lot more of what Mongoose has to offer. And then after we're done with a broad overview, we can work on our next project. I want to take a second to kind of reconsider or remember what we're working with when we touch Mongoose. When we work with Mongoose, we are working with kind of an interface to Mongo. Mongoose is all about just giving us a nicer API, something that has advanced functionality to work with Mongo. All of the operations that we've worked with so far, like specifically reading, writing, updating, and destroying data out of our Mongo database, is implemented by Mongoose, but we could have just as easily reached directly to Mongo and essentially had basically the same experience. So what I mean by that is everything we've done so far with Mongoose is kind of just a very nice little wrapper around Mongo, but essentially it's very close to us just reaching out to Mongo directly. What we're going to start to talk about now is a lot more of the advanced features around Mongoose that offer us great, awesome functionality around Mongo that is not implemented in Mongo at all by default. So we're going to start working with features that are special and implemented by Mongoose specifically to give us a way better experience when working with Mongo. The first feature that we're going to work with that's going to make us giddy with joy about how much nicer it is than working directly with Mongo is validation. Validation is the process of evaluating whether or not the properties of a record are safe to save to our database. I want to add a validation rule to our user model and say that a user must have a name longer than 2 characters in order to be considered valid. So in this case, we would consider Joe to be valid because it's 3 characters. A name of A, or maybe better than A would be Al, would be invalid because it's only 2, and Amanda would be valid because it's longer than 2 characters as well. Once a record or a model is marked as being invalid inside of Mongoose, it should not be able to be saved to our database. The purpose of validation is to make sure that we don't insert junk data into our database. We don't want users to be submitting or signing up with usernames that don't exist, or really short names, or this would even be a great way to prevent profanity inside of our usernames as well. This validation that we're about to add in is solely implemented by Mongoose, as we're using it at least. As at the validation level that we're using is 100% Mongoose. Mongo does have support for validation, but we are not directly working with it with the validation that we're about to use on the Mongoose side. Okay, so let's get started on this. Let's walk through an example of adding in some validation on our name property of our users. To learn more about validation on our users, we're going to take the same approach as we have with all of our other operations. I'm going to create a new test file, and inside of there, we'll write a test to kind of verify that validation is working the way that we would expect it to with Mongoose. So I'm going to start off by making a new test file inside of my test directory, and I'm going to call this one validation test.js. And then inside of here, we can place a little bit of our boilerplate that we've come to love so much. So we will require assert at the top. We will grab our user model. And then we'll place our describe block. And I'm going to give this a description of validating records. Okay, so now inside of here, we're not going to make a before each and declare Joe ahead of time. Remember, the whole purpose of validation is to say that we should not be able to insert a record to our database if the record isn't valid. So the entire purpose of our before each up to this point has been to make a record and then save it to our database just to avoid the repetitiveness of all that stuff. In this case, I want to specifically create records and then validate them without saving them to the database, so I'm not going to use the before each here. I will add my first it, and I'm going to say inside of here, requires a user name. So I expect that we should be able to write a test where we can create a new user, validate it somehow, and see an error message if we do not assign a username to it. Okay, so that's our goal. Let's start figuring out how we're going to implement this in the next section. In the last section, we started adding some code to test to make sure that we have a validation around a user's name. I specifically added a test named requires a user name here. And so just to be clear, we're going to add on two different validation rules. First, we're going to validate that a username was provided. And then second off, we're going to validate that the username that was provided is longer than 2 characters. So 2 separate rules. And so we're going to write 2 separate tests. We're going to first start off with the requires username, and then we will fill in the second test to make sure that the username is at least 2 characters long in the next section, or as the next test, excuse me. Okay, so let's get started with this. This first rule that we're adding to just require a property is definitely the easiest way or the easiest level of validation we can do. All it does is it says if we are going to save this record, a given property must not be undefined. So to specify this validation, we will add a new rule inside of our schema, inside of our user.js file. So I'm in the source directory in my user.js file, and I'm going to find my schema right here. So since we are adding a validation around a very particular property, we're going to add some more configuration in place of this type string right here. So instead of just saying a name should be a string, we're going to replace that with a full object. And then inside this object, we are going to add a bunch of different properties to describe not only the type of name, because we still have to specify the type, but we're also going to specify some of the validation options that we want to apply to the name property as well. So first, I'm going to add in a type of string. So notice that although I deleted the kind of annotation of the type, to say that name was a type and replaced it with the object, I'm still going to specify what type of property the name is going to be. So it's going to be a string, so I'm going to say type of string. Next, to make sure that Mongoose understands that the name is always going to be required, I'm going to pass in a required flag, and this is going to point at an array of true. And then the second element in here is going to be the message that we want to display whenever a name is not provided. So inside of here, it always makes sense to provide a very plain English error message, something that can eventually be shown to our user. So I'm going to say simply name is required. One of the biggest headaches around validation, and this is something that is common to just every web framework that I've ever worked with, is making sure that your validation errors can be shown as user-friendly messages. Okay, and what I mean by that is showing a user something like name is required on a form is 100% acceptable. It's totally reasonable, right? A user doesn't enter a name, yeah, you can say to them, name is required. Saying something to a user like user schema expected name prop or something like that, that is not a reasonable error message to show to a user. So you always want to make sure wherever possible, give your user some plain English thing that they can see. That really makes your job on the front end a lot easier, because on the front end, you won't have to look at this message right here and somehow translate it over to some English-friendly equivalent. So we're just going to go simply with name is required, like so. Okay, so as far as making sure that a property is required, this is all we got to do. So you'll notice that this is doing absolutely no validation around the length of a name that is provided. So we will come back later and add in that extra validation, but just making sure that something's required, this is it. So now that we've got this rule inside of here, we can flip over to our validation test file and add a test in here and make sure that the error message is going to show up as we expect. So inside of our it block, we are first going to create a new user, and we're going to specifically make sure that we are not giving it a name. We'll then validate the user that's created, and then we will make an assertion about the error message. So at the end of the day, I want to have something that says like assert error message is equal to name is required, or something similar to that. So we'll start off by making a new user. So I'm just going to give them, since they don't really have a name at all, we're saying specifically they're not giving a name, I'm going to assign them to a variable of lowercase u user. And we'll say this is going to be user. And then I will give them a name of undefined. And so the reason I'm doing this right here is to just be 100% explicit for the purpose of my tests. I could have just as easily left this entirely blank and just passed an empty object and would have the exact same effect. But I'm going to specifically pass in a name of undefined so that any other engineer who comes along in the future can see this and they can say, okay, clearly like they want name to be undefined here. The test must be doing something around the name of the user. So now that we've created the user, you'll notice that I'm not going to actually attempt to save it. I want to just specifically validate this model and then look at what is produced by that validation process. So I'm not going to save the model. Instead, I'm going to call a function on this thing, user.validateSync. Okay. This function will return an object that I'm going to refer to as the validation result. This validation result object right here is going to have all the results of validating the user model. So if we had a ton of properties wrong, like if this user is just absolute trash, there'll be a lot of different properties on the validation result that we can look at. The other thing I want to point your attention to is the validate_sync function. It's kind of a funny name, isn't it? Like validate_sync. This is to differentiate itself from a very similar but slightly different function called validate. The difference between validate and validate_sync is that validate_sync is a synchronous validation process. So we can call validate_sync, and in the exact same breath, in the exact same line, we'll get a result back about the validation. If we call just validate, this does not return a validation result. Instead, we can pass a callback function that will be called with our validation result. And then inside of this function, we can do something with that validation result. The reason that we would have validate with a callback function right here is to run any type of asynchronous validation that we might want to have. So perhaps whenever a user runs validation, maybe we need to reach out to our database or reach out to some web service or something like that and say, hey, is there already a user with like a name that has the same last name as this one? We can handle stuff like uniqueness at the database level. We would use, if we want to make sure that every user has a unique name, we can handle that in a different fashion. But if we want to have some really fancy validation, like see if this person has the same last name as anyone else who's ever been saved or something like that, that's where we would start to use the asynchronous method of validation, where we use a callback function. So because we're not doing anything like that, because we're just looking at the properties as they're given to us and then making a decision, are they valid or not instantly, we can use the validate sync. There we go, a function. So we call validate sync, we instantly get back a result. That's all. Okay, so now that we've got the validation result, I think that we're at a pretty good point in time where we could console log out this validation result and just see what it looks like. You know, what properties does it have? What do we have access to? So I'm going to add in a console log of validation result. Let's save this and flip over to our terminal just see what we get. So you'll see that when we get this validation result, we get what almost looks like an error message. It gives us an entire stack trace right here. So when a validation errors out, it actually produces an error object. And you'll see specifically it says right here, mongoose error. So this is not a normal object, it is an error object. And whenever JavaScript produces an error object, it's going to give us a stack trace as well. Looking at the error object itself, you can see that it's got a couple of interesting properties. So I'm going to scroll all the way up to the top of this thing. Okay, so here we go. Here's the very top. So the very top level thing, it's got an error. And then if we scroll back down, it has this errors property, which is what we really care about. We care about this errors property. The name produced an error. And so if we look at the errors produced, it is an object or an error object that says name is required, and then blah, blah, blah. You know, what I'm really trying to get at here is that it has this very nice, very well packaged up message property that we can get access to. So message right here, this is what we really care about at the end of the day, like 90% of the time. So we want to take this message and somehow show it to the user or log an error on our side. You know, maybe just our server say, hey, there was an error when we tried to save this record or something like that. So what we really care about is the message property on here. What's tough is actually getting access to that property. So as we just saw, like this thing is deeply nested on this error object, okay? Like deeply nested. And so I'm gonna save us a little bit of a headache. We can get access to that message property by referring to validation result .errors.name.message. Okay, so this is basically the map that we can use to get to the error message. Also notice that I'm going to use a little bit of ES6 here to clean this up. So because the last property that I care about is named message, and my variable that I'm assigning it to is named message as well, I'm going to take off message at the end, and I'm going to wrap message over here with some curly braces. So this is 100% equivalent ES6 code. Okay, finally, and I know this is a long section, but this is the very last step, we can add in an assertion. So I'm going to assert that message is equal to our error message that we just saw of name is required. And again, this is being produced by our message that we recorded in our schema file. So we said name is required. So I will assert name is required. Let's save this, check out our terminal, and yep, looks like specs are passing. Okay, so that's how we set up validation to require a specific property on a model. Let's continue in the next section and figure out how we add in some advanced rules around a validation or around a single property. So let's take a quick break. I'll see you in the next section. In the last section, we added in some validation to our user schema where we specifically required that the name must be a required property. So if a user ever tried to create a user without a name, we would return to them the message, name is required. In this section, we're going to move on a little bit by adding in an advanced validator on this name property. So required is great, but it just says, hey, was a value provided? It's very common that we want to add a validation on top of this thing to make sure that the user is passing something that is like actually well formatted. In this case, we want to add in a validation to ensure that the name is at least 2 characters long, or excuse me, longer than 2 characters, so at least 3 characters long. So Joe would be valid, Al would not. To add in a validation around a specific property, we can add another key to this configuration object being assigned to the name prop. So I'm going to add in another key here of validate. I'm going to assign an object to it. So validate will be looked at to find some information about how this thing or how this property should be validated whenever the validate function runs. We're going to assign 2 separate properties inside of this validate object. The first is one called validator, and it's going to be called as a function. Right now I'm just going to leave it empty. And the second will be the message that we want to show whenever the validator function fails, or whenever it returns specifically false. So because I expect my name to be at least 3 characters, I think that a reasonable message to show to a user whenever this validator fails would be something like name must be longer than 2 characters. So then the validator function that we provide right here will be called with the name property, just the name by itself. So I'm going to reference name like so. And then inside this function, so right here, we need to add some bit of logic that either returns true or false. If we return true from this function, then it will be assumed that the property is valid. If we return false, you guessed it, it's going to be invalid. So in practice, sometimes this is a very tiny function. Sometimes it might be very large, something that you might even want to break out to a separate function to be defined in this file, just to make everything a little bit more legible. So for us, we have a pretty straightforward validation. We just want to make sure that the name's length is longer than 2 characters. So I can say name.length is greater than 2. So if we have 3, hey, that's going to pass, everything's valid. If it's got a length of 0, it's going to fail, and we should see a message provided back to us of name must be longer than 2 characters. Okay, so validation in the schema, the important things to remember, you must pass a validate property. It should point at an object that has a validator function and a message to show if the record is invalid. So now that we've defined our validation, we can flip over to our validation test file and write a test to make sure that we can see this error message if the user is not valid. So I'm going to flip over to validation test, and then we'll add on a second it block. So it requires a username longer than 2 characters. You'll notice that I'm being a little bit inconsistent here by saying username. I really should just be saying name or the place. You know, we could just as well like put a quote in there and be like, okay, well, a user's name must be longer than 2 characters, but you get the idea. Okay, so in this function, we're going to end up with something that looks very similar to the test right above it. We'll create a user, we'll produce a validation result, and then we'll make an assertion about the message that is produced. So we will start off by making our user. I'm going to give them a name of Al, so just 2 characters. Then we will produce our validation result, which will be generated by validate sync, because we're not doing any asynchronous validation here. Everything is just a simple function that's going to run without making any asynchronous requests or anything like that. Then we can look at the message property from the validation result. It will should again be assigned to the errors.name property. If it's not, well, we'll see our test fail and we can fix it up. And then we can assert that the message is equal to the message that we just provided inside of our schema file, which should be name must be longer than 2 characters. So just to make sure I don't make any typos here, I'm just going to do a copy and I'll paste it over here. Okay, so I think this just about looks good. I'm going to save this. Let's see how our spec is looking. So when I flip over, okay, 15 successes, sounds good to me. Just to make sure everything's going correctly, I'm going to change the validation message inside my test, save it, and okay, fantastic, I get an error. You'll notice that I do that very often. I will like change my test even when it's passing just to see it fail. The idea behind testing, or I shouldn't say the idea, but definitely a very good practice, is to make sure that you see your test fail at least one time before you assume that it's running correctly. It could absolutely be the case that, especially in the case of the all the tests that we wrote with promises, so like here's one of the ones with a promise, it could entirely be the case that we accidentally chain on something like .10 or something like this. And it might be actually valid, right? And of course we have the done in here kind of as a catch or a safety, but all I'm really trying to get at here is that it's not entirely uncommon for us to have a test that might be accidentally passing, either because the assertion is not being called or because we wrote the assertion poorly. And so just to make sure that we don't make simple errors like that, a very quick thing to do is to just make the test fail one time, see it go red inside your terminal, and then you've got a at least somewhat reasonable feeling that, yeah, your test is actually doing the right thing to at least some degree. Okay, so we've seen a pretty straightforward example of validation. Let's continue the next section and work on another advanced topic. Before we move on to our next advanced topic, there was one last little thing that I want to talk about with validation. We've seen how to explicitly validate a record, and with both validate sync, and we also spoke a little bit about the validate function as well, but we haven't actually seen how these things get called in the wild, like how we actually call these in a real application. Traditionally, in a real application, we'll end up relying upon the fact that we cannot save invalid records to our database. So whenever we have an invalid record, so like a name or a user without a name or a user with a name that's really short, Mongoose will disallow us from inserting a record into the database. So I think it'd probably be a really good use of time to make sure that we get another test in here to make sure that's actually the case. So underneath our second test, I'm going to add on a third one. And I'm going to give this a description of disallows invalid records from being saved. And we'll add in our function with the done callback. So if we create an invalid record and then we just attempt to save it, like we're not even going to call validate sync or validate or anything like that, if we just attempt to save it, the save request should, or the save operation should just flat out fail, and we should be able to get access to some type of validation message, just like we saw before. So inside of this test, I'm going to create a new user. I'm going to make sure that they have some invalid attributes. So I'm going to give them a name of Al. So definitely invalid right now. Next, I'll call user.save. So whenever this save gets called, we should see a promise that gets rejected. So up till now, we've always been adding on a then case. But when a promise gets rejected, like in the case that user is invalid, we won't be dealing with a .then case. Instead, we'll be dealing with a .catch. So catch will be called if we try to save an invalid record. So inside this catch, we can add in a little bit of error handling logic, or at least in this case, an assertion to make sure that we got a validation result with the correct error message. So catch will be called with our validation result, and then we can add a identical assert to the ones that we've seen up here to make sure that validation result has our error message. So we'll say const message, and we've got our curly braces on here, again to make some use of ES6. Validation result dot errors dot name. So this is, again, the error message that we defined inside of our schema file, inside of our user model. So because we entered a username that is too short, again, I'm going to expect to see an error message of something like name must be longer than 2 characters. So I'm going to copy paste this string right here again, just so I don't have to risk any typos. And then we'll assert that message is equal to that error message we were just looking at. One thing that I really like to do whenever handling these error messages is certainly copy paste directly from the model file, the error message. It's incredibly easy to just drop off like, a period at the end or something like that. And then you end up with an assertion that's failing, and you'll sit there and wonder to yourself, why in the world is my assertion failing? This doesn't make any sense, because you don't notice that period at the very end. It's just a little bit of a tip there. So then after we make our assertion, because this was an asynchronous test, we need to make sure that we call our done callback. So I can add on done. We'll save it, and let's flip over to the terminal and see how we're doing. Cool, 16 tests passing now. So that means that we are successfully catching the fail to insert this new record into our database because it is not a valid record. So again, in practice, this is how you will usually see validation implemented. We'll attempt to save a record, and then if it successfully saves, we can send a response off to a user who's pending on a request or something like that. Or in the case that it's invalid, we can handle it appropriately inside of the catch statement. Okay, so now I think we're all in a good place with validation. Let's start tackling our next advanced topic in the next section.